Michio Kaku, what is the theory of everything?
The theory of everything is what drives hundreds of physicists around the world. And it could be the crowning achievement of 2,000 years of our investigation into the nature of matter. We want an equation, 1 inch long, that will allow us to, quote, read the mind of God. We want an equation that will summarize everything we know about the universe. Gravity, light, the electromagnetic force, the nuclear force. We want all of it into a single equation, which will give us not just the Big Bang, the formation of planets and galaxies, but even the formation of people, maybe even love. All of it in a theory that eluded Einstein for the last 30 years of his life. And today, we think we have it.
We do?
Yeah.
Why do we think that?
Because we have a theory called string theory. It is fantastic. It is incredible. It has astounded the world of mathematics and physics. And now you can't move in the physics world without bumping into somebody who wants to talk about the 10th dimension, the 11th dimension, the multiverse, hyperspace, time travel. All the things that were once considered science fiction are now centerpiece in our understanding of the nature of everything.
You called it a theory, however.
It's a theory because we are going to test it with the Large Hadron Collider. You know that Big Bang machine outside Geneva, Switzerland, that some people think is going to tear the world apart? Wrong. It's a machine of science. And we hope to create a mini Big Bang by slamming protons together near the speed of light, recreate a teeny weeny bit of Genesis, and from that, extract information that will show us that perhaps string theory really is a theory of everything. And that's what I do for a living. That's my day job.
Where did string theory come from, and who's the founder of it?
You're not going to believe this. In science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork. And in 1968, string theory was found by accident. Two postdocs, Veneziano and Suzuki, were looking through a math book, and came up with the beta function, which seemed to describe the collision of pi mesons. Why should a math book describe the intricacies of the collision of subatomic particles? Years later, we found out that it was a vibrating string that made all these things possible. What I did was, me and my colleague created a field theory of strings. What I did was I created an equation 1 inch long that will allow us to summarize all of string theory, all the equations of string theory. Now it's this huge, gigantic theory, hundreds of people working on it, and we hope to describe the results from the Large Hadron Collider outside Geneva, Switzerland, a $10 billion machine dedicated to unraveling the secret of nature itself.
What is that formula?
Well, everybody knows E equals mc squared. That equation is 1 inch long, and that's the secret of the stars. Matter, energy, they convert into each other, and that's why the stars shine at night. That's why we have the energy that lights up the universe. But Einstein was not satisfied with the theory of just energy. He wanted a theory of everything. Gravity, the electromagnetic force, all the forces wrapped up into a single equation. And then some people ask me, well, so what? I mean, can you get better color television this way? Can you get better cable reception? And the answer is, in some sense, yes. It is a theory of everything. When Newton unraveled the force of gravity, that gave us a mechanics, which gave us the Industrial Revolution. So the Industrial Revolution, in part, was set off by the discovery of the laws of gravity. Then Edison, Maxwell, Faraday worked out the laws of electricity and magnetism. And that gave us lasers and computers and the electric age. And then Einstein and others helped to work out the nuclear force, which lights up the stars. Now, we want a theory of everything, a theory of all forces. We want to create a superforce. And what did this superforce create? The universe itself. It is the driving force of creation. It's the energy of the Big Bang itself, the superforce.
Dr. Kaku, is Isaac Newton still relevant today?
Very definitely. Every time we launch a space probe and we send a space probe right past the rings of Saturn, right past Uranus and Neptune, you wonder, how do we do it? How do we send a space probe so close we could go whizzing right by the rings of Saturn, which is billions of miles away? And these are the laws of Isaac Newton, the laws you see around you that make skyscrapers possible, steam engines, locomotives, rocket ships. All of that is due to Isaac Newton. And then when you start to go near the speed of light, and you start to get exotic things like black holes and expanding universes, then you need the laws of Einstein. But even that's not enough, because once you approach the beginning of the universe, Einstein's equations break down. So at the Big Bang, Newton is out the window, Einstein is out the window, and at the Big Bang, we need a theory of a superforce, and that we think is superstring theory.
Is the theory of relativity fact?
Yes, it should not be called the theory of relativity. It's a law. Every time we accelerate particles near the speed of light, they never break the light barrier. Einstein is the cop on the block. You realize that relativity has been tested more than the traffic laws that we find in our neighborhood cities. Every time we launch a satellite, every time we shoot radio into outer space, every time we use a GPS, it all comes down to Einstein's theory of relativity. It's a law, not a theory.
Michio Kaku, in your book Hyperspace, you write, all physical knowledge at the fundamental level is contained in two pillars of physics, general relativity and the quantum theory. Einstein was the founder of the first, was the godfather of the second, and paved the way for the possible unification of both. What is quantum physics?
If you were to summarize all physical knowledge, I mean everything, the whole shooting match, lasers, microwaves, gases, liquids, everything into two great theories, they would be the theory of relativity, which gives us black holes and big bangs, the theory of the big. And then we have the theory of the small, that is atomic physics, which gives us laser beams, transistors, the internet. All the electronic wonders that we see around us are consequences of this quantum theory. The irony is, and this is the fundamental problem rocking all of physics, these two theories don't like each other. The theory of the big and the theory of the small hate each other. Every time you try to combine them, it's like a shotgun marriage. It never works. And this is where string theory comes in. String theory is the only theory in all the decades we've worked on this that actually merge these two into a single theory. It's amazing. They just like zip, form one coherent framework. Now, some people say, well, maybe I don't like string theory. Maybe I want another theory. Well, hey, there is none. This is the only game in town. No other theory has been able to combine the theory of the big, relativity, with the theory of the small, the quantum theory, into a single theory. This is the only game in town. So I tell young people, if you don't like it, create your own theory.
Is your job to disprove string theory?
No, my job is to put it into its final form. That is, it was discovered by accident in 1968, and we've been discovering all its secrets slowly year by year. The theory is smarter than us. We were, in some sense, not supposed to see this theory for maybe another 100 years. The theory is so advanced, and it fell into our lap accidentally, that we're just dazzled by the sophistication of the mathematics. Mathematicians have been shocked, absolutely shocked by the mathematics coming out of this theory. So my job is to put in its final form. When we have it in its final form, then we can start to compare it with the electrons, protons, neutrons that we see around us.
In Visions, Dr. Kaku, you write, the quantum theory is the most ridiculous theory ever proposed in the history of science, flying in the face of all common sense and intuition. The quantum theory opens the door to all sorts of sticky paradoxes which defy all our notions about the universe. The quantum theory has only one thing going for it. It is unquestionably correct. It has survived every experimental challenge hurled at it. Is it controversial in your world?
The quantum theory is only controversial when you talk to philosophers, theologians, and the average person. To a physicist, it's accurate to 1 part in 10 billion. We can take an atom, shine a laser beam at it, And I can predict the properties to 1 part in 10 billion. The consequences are the internet, GPS, laser beams, computers, fiber optics, a broadband internet. All of that is a consequence of the quantum theory. Now, you'd think that a theory that powerful would be logical, compelling, and intuitive. Wrong. It is the most bizarre theory ever proposed in the history of science. Einstein couldn't get his head around it. It reduces everything to probability so that there's a probability that electrons can vanish, reappear someplace else. Electrons can be 2 places at the same time and exist in multiple states at the same time. Now, that's stupid. I mean, how can you possibly exist 2 places at the same time? How can you be in multiple states simultaneously? Well, get used to it. That's just the way the atomic world is. So why don't I vanish and reappear someplace else, like on Mars or the Moon? There is a probability that I'll do that. In fact, we give our PhD students at our college a question. Calculate the probability that you will vanish and wind up on the planet Mars. Give me a number. It turns out you have to wait longer than the lifetime of the universe for that to happen. But it's a calculable number. This is insane. This is absolutely counterintuitive. But the problem is, it's right. That's how our world is constructed. Our world is stranger than you realize at the atomic level. Now, we don't see it because we average out all these bizarre quantum effects for large objects. We consist of a lot of atoms. But at the atomic level, electrons exist in multiple states all the time. And you know what that's called? That's called the laser beam.
Good afternoon, and welcome to Book TV's In-Depth program. This is our monthly program where we feature one author and his or her body of work. This month, it's physicist and author Michio Kaku from the City College of New York. He is the author of about 8 books, 6 of which are readable. The others are textbooks, and unless you're an advanced student in physics, I'm not sure that they would apply here. But if you would like to call in and talk with Dr. Kaku, here are the numbers. 202 is the area code. If you live in the East or Central time zone, 737-0001 is the number for you to call. Those of you in the Mountain and Pacific time zones, 202-737-0002. You can also send us an email at booktv@cspan.org. We will be live with Dr. Kaku for the next 3 hours. Doctor, you write in your book Hyperspace. First of all, what is hyperspace?
Hyperspace is dimensions beyond the visible universe. Everybody knows the universe is expanding. But then the question is, what is the universe expanding into? The universe, we think, is expanding into another dimension. So think of a balloon. If you have a bug on a balloon, the bug would say, well, my balloon is expanding. I can measure the rate at which the balloon expands. But then you ask the bug, well, what are you expanding into? And the bug will say, I don't know. The balloon is all there is. The universe is the balloon. So what is a balloon expanding into? Well, obviously the 3rd dimension. We think our balloon is expanding into 11-dimensional hyperspace. Now, get your head around that. We're way beyond the 4th dimension. We think that the instant of creation was basically a quantum fluctuation in 11-dimensional hyperspace.
Why 11?
It turns out if you construct a universe of 13, 15 dimensions, the universe is mathematically unstable. The mathematics shows that these universes topple down to 11 dimensions. You can't escape it. String theory is the only theory which selects its own dimensionality. You can write Newton's laws in any dimension you want. You can write Einstein's equation in any dimension you want. But why do we exist in 3 dimensions? For the first time in history, we now have a theory which actually selects its own dimensionality, because these other dimensions are unstable. And then 11 dimensions, we think, ultimately collapses down to the 3-dimensional universe that we see and touch.
What's the 4th dimension?
Well, Einstein says the 4th dimension is time. So if you want to meet somebody in Times Square, you say, meet me on 42nd Street, 5th Avenue, 10th floor at noontime. So it takes 4 numbers to specify lunch in Manhattan. But we now believe there could be other dimensions, perhaps as many as 11 dimensions. And we hope to test these ideas with the Large Hadron Collider.
Is there an LHC type device here in the States?
We once had dreams of building a super collider outside Dallas, Texas. It was to be much bigger, about 3 times bigger than the puny pea shooter in Geneva, Switzerland. On the last day of hearing, a congressman asked a physicist, quote, "Will we find God with your machine? If so, I will vote for it." Well, the poor physicist didn't know what to say, so he said, "We'll find the Higgs boson." Well, the vote was taken the next day, and people were saying, $11 billion for another god-darn subatomic particle. And they took a vote, and it was canceled. Now, since then, we physicists have been mulling that question over and over in our minds. How should we have answered that question? Will we find God with your machine? If so, I will vote for it. I would have said the following. I would have said God, by whatever signs or symbols you ascribe to the deity. This machine will take us as close as humanly possible to his or her greatest creation, Genesis. This is a Genesis machine. It will recreate on a small scale the most glorious event in the history of the universe, its birth. Unfortunately, we said Higgs boson, and our machine was canceled. $11 billion out the window, and now the Vatican of physics is not Dallas, Texas. The Vatican of physics is Geneva, Switzerland. There's a brain drain. My friends, some of my friends are leaving the United States to go to the new Vatican of physics, Geneva, in part because our politicians thought it was a waste of time to fund science.
What about the Fermilab operation in Chicago?
That machine is old. Eventually, it'll be shut down. It is the second largest machine, but the Large Hadron Collider today is way beyond the Fermilab. So the Fermilab will eventually become probably a museum of sorts because it's not at the cutting edge. And there's a lesson here, and that is there's a price you pay for being on the cutting edge of science. The benefits are enormous. The industrial age, the steam engine, transistors, lasers, space satellites. Those are the benefits of being on the cutting edge. The downside is, if you're not on the cutting edge, somebody else will be on the cutting edge and leave you in the dust. So that's the lesson. The cancellation of our super collider has created the new Vatican of physics, Geneva, Switzerland.
Do you believe in a God?
I would believe in the God of Einstein. Einstein was asked this question many times. And he said, look, there are 2 kinds of God. So let's be clear about this. The first God is the personal God. The God that answers prayers, the God of Isaac, Moses, Jacob, the God that parts the sea and walks on water. The God that answers prayers, the personal God. Einstein said that no, he believed in this other God. The God of Spinoza and Leibniz, the God of reason, the God of beauty, elegance, simplicity. That it's amazing that the laws of science are very simple, very elegant, very mathematical, and it couldn't have been an accident. He said to himself that, look, we are like children entering this huge library, this cavernous library. All we can do is take the first book, open up and read the first page of this first book of this cavernous library. And so he said that he believed in the God of order, the God of simplicity and harmony.
And in hyperspace, you write, when scientists use the word God, they usually mean the God of order. However, to the non-scientists, the word God almost universally refers to the God of miracles. And this is a source of miscommunication between scientists and non-scientists. Why are theologians opposed or concerned about string theory?
Every time a new radical discovery comes out of quantum mechanics and atomic physics, the theologians come and start to debate us. When the uncertainty principle came out, for example, in around 1925, and we said that there's uncertainty in the world, Newtonian physics is overthrown, the theologians came back at us and said, what about free will? I mean, are we deterministic? Is there a book in heaven that says you will go to hell, you will go to heaven, or is there uncertainty in the world? Now we realize that there could be other dimensions, a multiverse of universes. Just realize that 400 years ago, the Catholic Church burned alive Giordano Bruno, a renegade Jesuit monk, who said that there are other life forms in outer space. For that, he was burned alive in the streets of Rome. Now we're saying that not only could there be other life forms in outer space, we're talking about a multiverse of universes. Our universe could be just one bubble floating among other bubbles out there. And Stephen Hawking, my colleague, made headlines just last month by stating that maybe God isn't necessary anymore. Here's Stephen Hawking's reasoning. He says, first of all, that physicists are the only scientists who can say the word God and not blush. But if you want to see a physicist blush, ask him what happened before the Big Bang. Well, string theory is a theory of everything. If it's correct, it means you can go before the Big Bang, before creation itself. Maybe our bubble universe bumped into another universe, creating a bigger universe. Maybe it budded off, fission, peeled off a balloon that simply splits in half. Maybe that's the Big Bang. And then Stephen Hawking said, well, if this is perpetual and we don't need a God to set it into motion, then maybe God is unnecessary. Now, I take a different point of view on this question. I would say, well, yeah, maybe God is not necessary to create a Big Bang. But then, who created string theory? Where did the theory come from? Where did the mathematics come from? And at that point, physicists stop. Okay? So we can go before the Big Bang. We're not embarrassed about that anymore. But then the question is, where did the law come from? Who is the lawgiver? God is supposed to be the lawgiver. If the law is string theory, where did that theory come from? And I think even Stephen Hawking would say, I don't know.
Michio Kaku is our guest on In Depth. Here is a list of his books. Beginning in 1995, Beyond Einstein, The Cosmic Quest for the Theory of the Universe. Then also in 1995, Hyperspace, a scientific odyssey through parallel universes, time warps, and the 10th dimension. Visions came out in 1999, How Science Will Revolutionize the 21st Century and Beyond. And in 2005, Einstein's Cosmos, How Albert Einstein's Vision Transformed Our Understanding of Space and Time. 2006 brought us Parallel Worlds, A Journey Through Creation, Higher Dimensions, and the Future of the Cosmos. And in 2008, Dr. Kaku's most recent book, Physics of the Impossible, a scientific exploration into the world of phasers, force fields, teleportation, and time travel. Dr. Kaku, in reading your books, you make many references to popular culture, Star Trek, Back to the Future, Isaac Asimov. Why?
It goes back to my childhood. When I was 8 years old, everyone was talking about the fact that a great scientist had just died. And they showed a picture of his desk with his book, unfinished manuscript. And to me, this was incredible. How could the greatest scientist of our time not finish this problem? Well, it was Einstein's unified field theory. But at that time, I also was doing something else. I was watching television. Every Saturday morning, I watched the Flash Gordon series on TV with Buster Crabbe. I mean, I was floored. For the first time, I saw evidence of alien civilization, starships, ray guns, city in the sky, anti-gravity, all the things that I never even thought of before. And then I began to realize something. I began to realize, first of all, I didn't have muscles and blonde hair. I wasn't an Olympic swimmer like Buster Crabbe. But it was the scientist who made everything work. So it was Dr. Zarkov with his starship, with his city in the sky, with his ray guns. Without science, there's no Flash Gordon. And so I said to myself, well, these are two passions of my life. One is to understand physics. The other is to understand the future and science fiction. Maybe they are actually the same thing. The two passions of my life are really the same. Because to understand time travel, to understand dimensional gateways, to understand antimatter, the fourth dimension, you need the most advanced physics there is, which is string theory. And so I thought to myself, wow, I can merge the two great loves of my life. So I'll admit it, I'm a Trekkie. I've watched all the Star Trek movies, all the Star Wars movies. I love this stuff, okay, because it forces you to open your imagination. Now, to be fair, sometimes I kind of like grit my teeth watching these science fiction movies because I say to myself, well, that's not right. No, that's not right. No, that's wrong. That's not right. But then I say to myself, hey, relax. Enjoy the show. Go with the flow and have some fun.
You host radio science shows, and you also host a show on the Science Fiction Channel.
Science Channel, that's right.
Science
it's called Sci-Fi Science. It's one of the highest rated shows on the Science Channel. First season, 12 episodes about starships and building a time machine and going to another dimension. Second season we're in right now, every Wednesday night, another 12 episodes, making contact with alien civilizations in outer space, how to deflect meteors, what happens when robots become super powerful. These are all subjects that we take in the second season. And, you know, some people ask me, well, why do this? And one thing is that I get to interview the world's top scientists in all these fields. So altogether, I've interviewed about 300 of the world's top scientists. So when I talk to them about the future, it's just not some science fiction writer just BSing about what he thinks the future is going to be. I'm talking to the scientists who are inventing the future in their laboratories. I have a front row seat to be able to get on the telephone, talk to Nobel laureates, directors of the major laboratories, and say, what is your dream? What do you think 2050, 2100 is going to look like? And to me, that's a thrill of a lifetime. Because instead of speculating, instead of moaning and groaning about when we're going to have flying cars, I can talk to the people who are inventing the future.
Well, in Parallel Worlds, you discuss time travel. Is it possible?
It could very well be possible. Stephen Hawking has said that, yes, time travel is possible, but not practical. In other words, don't expect an inventor to create a time machine in their basement today. We're talking about the energy of a star, the energy of a black hole. But in principle, if you could master that energy, then you might be able to bend time into a pretzel. The mathematics says so. Even Albert Einstein realized in 1949, his own equations allow you to go backwards in time. If the universe rotated, for example, a very simple kind of universe, a rotating universe, and you go with the flow, you go around the universe as it rotates, you can come back into the past. So simply walking around a circle, you come back not where you left, but you come back yesterday. So even Einstein realized, oh my God, his own equations allow for time travel. So in his memoirs, of course, Einstein had to address the question, is time travel possible? And he said, aha, I have found a loophole. And that is, the universe expands. It doesn't rotate. So it means that if the universe rotated, time travel would become commonplace. So thank goodness the universe expands.
Well, we have this email in for you that kind of fits into what you were just talking about. Very simple. How did the cosmos begin, and how will it end?
Well, we think the universe began with a cosmic explosion 13.7 billion years ago. We know that number to within 1% accuracy, in fact.
How do we know that?
Well, we know the rate at which the universe is expanding. Stars, for example, yellow light from stars is stretched because they're moving away from us, and they turn reddish as a consequence. That's called the Doppler shift. When a car moves toward you, for example, the frequency is high. When a car moves away from you, the frequency is stretched or lowered. It sounds like this. Now, you've heard that all your life. But what is that? That's a Doppler effect. It also works for light beams. When yellow light comes toward you, it's bluish. When yellow light moves away from you, it's reddish. The redder it is, the faster it moves. So it's trivial to calculate the expansion of the universe. You simply look at the night sky and see how much the light is redshifted. Then you run the videotape backwards. We have this enormous, quote, videotape on computer of the expanding universe, so we run it backwards. You've all seen explosions run backwards on television. And then you get back to the point where the universe was a small little dot. That's how we know the universe began, with a fiery explosion. And we can also pick up the afterglow of the Big Bang. When you get a radio and you turn it between stations, you get that static, that zzz static. Believe it or not, a few percent of that static comes from the Big Bang itself. You were actually listening to Genesis on your radio. Your television set, when you have snow on your TV set, a few percent of that snow comes from the creation of the universe. More percent comes from planet Jupiter. Planet Jupiter also causes static on the Earth, which is more than the Big Bang. But we physicists have measured that microwave background radiation. We now have baby pictures of the infant universe. And you know what? It's an explosion. We have baby pictures of the explosion itself. And sure enough, it is a gigantic explosion, just like everyone thought. And we've actually now taken pictures of it in the microwave region. The big question is, how will the universe end? There are two ways it could end, in fire or ice. If it ends in ice, the universe keeps on expanding and gets colder and colder and colder. Or the universe could expand, stop, and then come back and get hotter and hotter and hotter in the big crunch. Either way, the laws of physics say we're doomed. Either we're going to die in fire or die in ice. But there's one way out of this death. The question is, the laws of physics, are they a death warrant for all intelligent life? Most physicists would say yes, that inherent within physics is a death warrant for all intelligent life in the universe, because either the universe dies in ice as it expands or dies in fire as it contracts. I think there's a loophole. The loophole is that billions, trillions of years from now we'll be so advanced that as the universe dies, we will leave the universe. We will leave our bubble, have a lifeboat, and then go to another neighboring bubble and start all over again. So in other words, this theory of everything may ultimately be the theory of salvation for intelligent life in the universe. Now that's speculation, but in parallel worlds, I even give you the blueprint, the design, how much energy it would take to build a machine which would take us to a neighboring universe.
And is that going to happen in the next week or so?
No. I wouldn't buy an insurance policy anticipating the death of the universe. We're talking about billions, trillions of years from now. We still debate exactly how it's going to happen. Right now, the data seems to favor the big freeze. The data seems to favor the fact that we will all freeze to death billions, trillions of years into the future.
All right, we've got all sorts of callers on hold, and we're going to get to those right after this email. David Moshinsky, Claremont, Florida. My reading of M theory and string theory indicates that there are an infinite number of universes. I recall from math studies that if there are an infinite number of universes, anything can happen, and will happen an infinite number of times.
Well, even in the quantum theory, forget string theory, even in the quantum theory, our universe coexists with other parallel universes. So our universe is constantly splitting into different universes with different outcomes. Then comes the big question that everyone wants to know the answer to. Is Elvis Presley still alive in one of these other universes? And the answer is, in some sense, yes. In some sense, our loved ones who have perished in our universe could be alive in another parallel universe. And then the question is, well, where are these parallel universes? And the answer is, they're in your living room. We coexist in the same space with these other universes. Now, Steve Weinberg, Nobel laureate, compares it this way. Think of radio. If I have a radio receiver and I turn to one frequency, you get a nice, clear musical signal. But in that same living room, you coexist with radio from all frequencies. You get radio Havana, radio Moscow, radio Beijing. You get all these different frequencies right in your living room. You coexist with all frequencies. But your radio is tuned to just one frequency. In the same way, in your living room, there is the wave function of dinosaurs. In your living room, there's the wave functions of the loved ones that you cherished who are dead but are still alive in a parallel universe. They're right in your living room, but we're not coherent. We're not tuned into them. Our frequency is different. Therefore, for all intents and purposes, we cannot communicate with them. So even in the ordinary quantum theory, the theory of lasers, the theory of optics, the theory of GPS, the internet, broadband, even in ordinary quantum mechanics, we have this infinite set of universes. Now, string theory goes even farther and says these universes could be in higher dimensions. And maybe protons and neutrons are not stable. So string theory has an even larger set of infinite universes. So what do we make of this? Our universe is rather stable. To go to a neighboring universe would require technology far beyond anything that we can muster. So don't think you're going to wake up on Mars tomorrow. Don't think you're going to meet a dinosaur tomorrow. It's not going to happen.
Michio Kaku is our guest. Butch from Jackson, Wyoming, you're first up. Go ahead with your question.
It's a privilege. My mentor, who I'm not going to mention, talked about different dimensions. He says that there is life on Mars, and they see Earth as desolate and dead, as we see Mars, because they're in a different dimension and they see us from a different dimension. He says the inner universe would make the outer universe the size of a pinhead, and that there is something past the speed of light, and it's called a thought. I'd like to know what your response to is that. Thank you.
Well, Butch, you raise a lot of very interesting questions. First of all, can other beings exist in these other dimensions, these other universes? And the answer is yes. In fact, if you take a look at string theory, you take a look at ordinary quantum theory, the theory of 1925, that theory also makes this possible. However, and here's a catch, and it's a very big catch, communicating between dimensions is extremely difficult. Most physicists would say impossible. I wouldn't go that far. I think it is possible, but extremely difficult with our technology. Now, on Mars, you mentioned the possibility of life. Well, in our universe, we see no evidence of life on Mars, not even microbial life. However, no one's ever looked underground. Maybe in the polar ice caps, maybe in the permafrost underground, maybe there are evidence of intelligent life forms. However, none of our space probes have ever gone underground into the ice caps or into the permafrost. But even if there was a civilization on Mars, communication between us would be extremely difficult. It would require what we physicists call a type 3 civilizations technology, and we're basically a type 0 civilization. So don't think we're going to be able to communicate with other dimensions and with other beings anytime soon.
What's a type 0 civilization, and are we near being a type 1 in your view?
We physicists rank civilizations not by politicians and great men and great leaders. We rank them by energy. A type 1 civilization has mastered planetary energy, all the energy of the sun that falls on their planet, the weather, earthquakes, volcanoes. They play with hurricanes. That's type 1, like Buck Rogers or Flash Gordon. A type 2 civilization plays with stars. That's the next level of energy. And Star Trek and the Federation of Planets is just beginning to play with stars and nearby star systems. That would be a type 2 civilization. Then there's type 3, galactic. They have harnessed the power of maybe 100 billion star systems, like Independence Day, like Star Wars, like the Borg on Star Trek. Now, on this scale, are we type 1 that control hurricanes? Are we type 2 that control star systems? Are we type 3 that roam the galactic space lanes? No, we're type 0. We get our energy from dead plants, oil and coal. But we can dream. In fact, if you take out a calculator, you can show that we are about 100 years away from being a type 1 civilization. And you see evidence of this everywhere I go. The internet. What is the internet? The internet is the beginning of a type 1 telephone system. So we're privileged to be alive to see the birth pangs of a type 1 civilization. What language will this type 1 civilization speak? Probably English. It is already the #1 second language on the planet Earth, the language of science, commerce, art. If you take a look at the economy, we're witnessing the beginning of a type 1 economy. The European Union. These nations have slaughtered each other ever since the ice melted 10,000 years ago, and now they're forming a single bloc. And why are they ganging together? To compete against us, NAFTA. So we're seeing the beginning of a type 1 economy. We're seeing the beginning of a type 1 culture with rock and roll. What is blue jeans? What is rock and roll? What is Chanel and Louis Vuitton? The beginning of a type 1 culture. And there's a backlash. There are some people who don't like this transition to type 1, people who are fundamentalists, terrorists, for example. They prefer be more comfortable not 100 years in the future. They would rather be 500 years into the past. So we see the birth pangs of the beginning of type 1. And I personally think that is perhaps the greatest transition in the history of human civilization. From the fragmented, rather backward civilization of today to a planetary civilization 100 years from now.
Next call, St. Petersburg, Florida. Gary, go ahead.
Hey, guys. Doc, I'm holding a book in my hand right now, Einstein's Ideas and Opinions.
Mm-hmm.
And it's one paragraph, and I want you to explain this to me, what he was driving at. It's only 5 sentences, but it says, in my opinion, the present manifestation of decadence are explained by the fact that economic and technological developments have highly intensified the struggle for existence, greatly to the detriment of the free development of the individual. But the development of technology means that less and less work is needed from the individual for the satisfaction of the community's needs. A planned division of labor is becoming more and more of a crying necessity, and this division will lead to the material security of the individual. The security and the spare time and energy which the individual will have at his disposal can be turned to development of his personality. In this way, the community may regain its health, and we will hope that future historians will explain the morbid symptoms of present-day society as the childhood ailments of an aspiring humanity, due entirely to the excessive speed at which civilization was advancing.
All right, Gary,
Okay.
what would you like Dr. Kaku to respond to?
What was he driving at there?
All right, thank you.
Okay. Einstein at length wrote about the fact that technology is a double-edged sword. On one hand, technology gives us a division of labor. We're not simply nomads in a tribe wandering across the desert anymore. We have layers. We have leaders. We have craftsmen. We have farmers. We have a division of labor. And with that division of labor comes two things. A, inequity. That is the disparity between the rich and the poor, the powerful and the weak. But on the other hand, progress. Medicine, energy. We no longer have to do back-breaking work. We can now span the oceans and span the globe and communicate with each other. So he was just mentioning the fact that science is a double-edged sword. The question is, which part of the sword will dominate? Is it the part that gives us a liberating society that's educated and scientific, or a society that's fragmented into hierarchies that are permanent and embedded into a system of inequity? So that's what he was getting at. And it's up to us. It's up to us to decide which way we'll go. And I think that ties in with what I said about a type 1 civilization. On one hand, we have the trend toward a type 1 civilization, scientific, multicultural, tolerant, but on the other side, a tendency toward fundamentalism and racism and sectarianism and terrorism. And it's not clear which of the two trends will eventually dominate.
Email has come in for you. Science makes a discovery, then allows society to decide how that discovery is used. This person quotes Isaac Asimov. The saddest aspect of life right now is that science gathers knowledge faster than society gathers wisdom. Please discuss what you think about the passive role taken by the scientific community by not suggesting desired applications for their discovery, the purpose of that policy, the results of that policy, and the future of that policy. Thanks, I want your job, this writer says.
Well, I think that writer asked a lot of very, very deep questions. First of all, science is the engine of prosperity. However, on the media, you'd never know that. The media is fixated on Hollywood symbols, Lindsay Lohan's in Paris, Hilton's latest hijinks. Well, that's okay. But where is science in all of this? Science is invisible for two reasons. One is the big producers and moguls say that, well, science doesn't sell. And second, scientists themselves would rather be locked up in an ivory tower, chasing after whatever microbes or DNA molecules or subatomic particles that interest them. On one hand, we have to realize that science does sell. Realize that if you take a look at the Discovery Channel and Science Channel, National Geographic and History Channel, we see an explosion of science programming that simply didn't exist 10, 15 years ago. There is a demand for science programming if it's done well. But on the other hand, where are the scientists out there that can then tell people how important it is, why they should appreciate science, and why they should fund science with their taxpayers' money? And part of it is habit during the Cold War. we were spoiled. We got our inventions, our machines. We would go to Congress and basically say one word. We go to Congress and say, Russia. And then Congress would whip out a checkbook and say, how much? That's how we got our atom smashers. That's how we got our big machines. That's how big science was funded. Well, Congress figured it out. Russia is not building gigantic machines anymore, and we can't use the excuse of the Cold War to get our budgets funded. Now we scientists have to learn how to communicate directly to the American people. We have to, quote, learn how to sing for our supper, or else they're going to cancel our super colliders, or else they will cancel our machines. Now, sometimes in the scientific world, they say, well, don't engage with the public. They're ignorant. You'll be misinterpreted. It's not worth it. But hey, let's face it, your budget's going to get cut unless you can tell the American people why the taxpayers' money is going for good causes, why it will cure disease, why it will solve the mysteries of the universe, give us new exciting technologies. It's up to us to get into the political fray.
Michio Kaku, you write in Visions, in the U.S., the best scientific minds are often absorbed by the Pentagon, which uses their talents on new generations of weapons. Even redirecting a tiny percentage of the military budget to pure science could have a profound effect on the development of technology. What about the National Science Foundation? What about our system of national laboratories? What about private enterprise?
If you take a look at the system of national laboratories, they really have done the yeoman's work of pushing the boundaries of science. But you know, hey, we're entering a new period, a period where the best minds and the funding is not necessarily going into that direction. I once had lunch with Freeman Dyson, very well-known physicist, and he grew up in England in the 30s. And he said there was a very disturbing feature of England in the 30s, that it was a society in decline. It was decaying. All the best minds were no longer going into engineering and chemistry and physics. The best minds were going into the London Stock Exchange. They were learning how to massage other people's money rather than create wealth, create chemical factories and new inventions. And then he said something which really shocked me. He said, I see it for the second time. For the second time in my life, he says, I've seen the same pattern. Just like England of the 20s and 30s with the best minds going into coupon clipping and stocks and bonds and stuff like that, massaging other people's money rather than creating wealth. Today at Princeton, he said, where he teaches, it's happening again. The best minds are going into investment banking, massaging other people's money rather than going into physics and chemistry. Well, we all know what happened to Wall Street. It imploded. The best minds of a generation imploded our economy, and we see the consequences that our scientific establishment is eroding as a consequence. Let me give you an example. In the United States, 50% of all PhD physicists are, in graduate school, are foreign-born, 50%. At City University of New York, it's 100% are foreign-born. What we're witnessing is a hemorrhaging of our scientific elite, compensated for by foreigners who then populate our PhD institutions. Now, however, as you've been reading in the papers, China is saying, come on back. The water is fine in China. We'll give you a laboratory. We'll give you whatever you want if you come back to China. Well, this is unstable. It can't last. Remember, the British began to decline when their scientific establishment began to crumble. Our scientific establishment has been maintained by a brain drain. We still get the best scientists around the world and send them to Silicon Valley. 50% of Silicon Valley, by the way, is foreign-born. 50% of the scientists there are foreign-born. But it's unstable. It can't last forever, especially because the Indians and the Chinese are saying, come on back, the water's fine. You don't have to be in the United States anymore. So I think it's a warning. It's basically the canary in the mine shaft telling us, watch out. We could go the same way as England.
Are we recognizing that? Are we funding differently? Are we encouraging differently?
No. Take a look at the media and the debate. Almost all the debate is about redistributing wealth, massaging wealth, rearranging wealth. But the question is, who is creating new wealth? Who's creating the next transistor, the next steam engine, the next light bulb, the next internal combustion engine, the next laser, the next satellite. Who are creating these things? Well, don't be surprised if one day it's going to be the Chinese and the Indians. Now, I don't want to scare people. I'm saying that you can see the beginning of this erosion today. The best minds not going into the hard sciences, but going to Wall Street, where they basically implode the economy.
And from Hyperspace, one of Dr. Kaku's books, more than half the gross national product of the Earth, representing the accumulated wealth of the planet, depends in some way on the electromagnetic force. Tucson, Arizona. Frank, hi.
Hi, Professor. I really enjoy your efforts to make very difficult concepts understandable by the layman.
Thank you.
I've got a pretty good knowledge, I think, of physics. I had a little trouble with Einstein relativity, but I think I got some of that. But I'm really having trouble with string theory. It doesn't seem to be testable, which at least, as you mentioned earlier, relativity is now a law rather than a theory. Could you help me out in understanding string theory?
I'd be delighted to.
We've talked about it a little bit, but if there's another twist that you can put onto it to help him, that would be great.
Think of music. If you take a violin and string, or even a rubber band, different vibratory notes on a rubber band corresponds to a subatomic particle. So if I take an electron and look at it with a super microscope, I would see that the electron is not a dot, it's actually a rubber band. And if I twang the rubber band, it turns into a neutrino. I twang it again, it turns into a quark. And I twang it enough times, and it turns into the hundreds of subatomic particles that we see in our atom smashers. So the notes on a tiny, tiny string correspond to all the subatomic particles. Physics corresponds to the harmonies governing rubber bands. Then chemistry corresponds to the melodies you can play on rubber bands that bump into each other. The universe is a symphony of strings, and the mind of God that Albert Einstein wrote about for 30 years of his life, would be cosmic music resonating through 11-dimensional hyperspace. These are not ordinary strings and membranes. They're resonating in 11-dimensional hyperspace. And then you may say, well, that's fine and good, but prove it. Well, with the Large Hadron Collider, we hope to create sparticles. Sparticles are super particles representing the next set of vibrations on a rubber band. Everything you see around us is the lowest octave of a vibrating string, but the vibrating string has higher octaves. And the next higher octave could be sparticles, which we hope to create with the Large Hadron Collider. And one example of a sparticle, we think, is dark matter. If you've been reading all the cosmology websites, you know that dark matter is invisible matter, but it makes up most of the matter of the universe. The universe is not made out of atoms so much. Every chemistry book is wrong. Every chemistry book says the universe is made out of atoms. End of story, period. Wrong. The universe is made out of dark matter, and we think dark matter could be a higher vibration of the string, and we will create dark matter, we hope, with the Large Hadron Collider. So all theories are testable, including string theory.
In Parallel Worlds, you write that 73% of the universe, or the cosmos, whatever, is unknown energy.
This is embarrassing. If you want to win a Nobel Prize, explain what is dark energy and dark matter. Now, we think we're so great. Atoms of oxygen, carbon, nitrogen, we think that's the universe. The atoms of our body, the higher atoms, make up 0.03% of the universe. Let me repeat that again. 0.03% of the universe is carbon, nitrogen, oxygen. 4% is hydrogen and helium. The rest, 96%, is dark matter and dark energy.
Why don't we know? Why don't we know what it is?
Because it's not made out of the familiar atoms that we can see and touch in our laboratory. They're very elusive. If I have dark matter in my hand right now, it would be first invisible. Second, it would filter right through my fingers, go right through the floor, go all the way to the center of the earth, and all the way to China. Reverse direction in China, and then come all the way back to my hand. Have you ever seen that before? That's what dark matter can do. And the Earth moves in a wind of dark matter, and we're going to try to measure that wind with our machines. We have gigantic vats of hydrogen fluid that we hope to detect the wind that we are moving in. So this is big science, multi-billion-dollar experiments, the Large Hadron Collider, experiments on dark matter. This is the cutting edge, realizing that every chemistry book is wrong. The universe is not mainly made out of atoms.
Dr. Kaku, when people read about the LHC in 100 years, will they think, oh, that's quaint? Oh, apple falling on Newton's head?
Yeah, they will definitely think it's quaint. That machine is, what, 27 miles in circumference. It's probably bigger than the city of Geneva. You could put Geneva inside the machine. And we will think it's quaint because in the future, we hope to create what are called tabletop accelerators. They exist on a small scale, but in terms of energy input per meter, we can get machines that are only a few meters long that will accelerate particles to billions of electron volts, once thought to be impossible. So perhaps in the future we'll have tabletop particle accelerators.
Next call for Dr. Michio Kaku, who is our guest this month on Book TV's In Depth. Todd in Wixom, Michigan. Hi, Todd.
Hi. That truly is an honor to speak to you, sir. You answered one of my questions about the time travel, but while you were speaking, I got a comment and possibly a question how you personally feel. It's amazing how far man has advanced technologically, but it's also amazing how little he himself has changed. Now, I remember you saying that you were a Star Trek fan, but as I recall, in order to achieve membership in the international space community, they had to overcome greed and capitalism and social injustice and all that so they could concentrate all their efforts on moving forward. Now, my personal question to you is, what at this time is more important, social equality and helping your fellow man or technological advances? Thank you.
You ask a very good question. What is more important, helping society get richer and wealthier or scientific experiment? Well, you can't divorce the two, because where does wealth come from? Where did the transistor come from? The laser beam, the GPS system, the internet, the steam engine, the light bulb. These are sources of every technology you see around us. The wealth of nations, the high standard of living that we enjoy today is a direct byproduct of the steam engine, the laser, the transistor, the computer. So science is the driving force that makes possible the elevation of society. Realize that just a few hundred years ago, we had a tiny percentage of human population being kings and queens and nobles, and about 99% of the human population living in an abject poverty, grinding, back-breaking poverty. That changed with the coming of the steam engine and the Industrial Revolution, and that helped to create a middle class. So the middle class that we are witnessing, for example, growing in China right before our eyes, is a direct consequence of the technology, the inventions, and the Chinese are very clear about this. Why are they sending all their PhD students to America where I see them? In fact, one of my graduate students was, in fact, Chinese. Half our physics department is foreign. 100% of our physics department is actually foreign-born in terms of the PhD program. So the Chinese understand this. They make no bones about it, that they want to get as much of science and technology because the West, lives off its laurels. They know, the Chinese know, that this is going to be the source of their wealth. It's a meal ticket to the future. Now, you also mentioned the fact that we are very backward socially. And part of that fact is that our brain, our personalities haven't changed for 100,000 years. 100,000 years ago, the best evidence shows that modern humans that look just like us, you give them a haircut, a three-piece suit, put them on Wall Street, they look like all the other barbarians on Wall Street. People just like us emerged from Africa 100,000 years ago. That's why societies are so painfully backward, while inventions can travel at the speed of light. And that's the reason why, on one hand, we reach for the stars, but on the other hand, we have feet of clay, which is very sad. But again, it's the march of science that eventually creates the industries that will enrich. So you can't separate the two. However, on television, the entire debate on television is who gets to rob Peter to pay Paul? How are we going to redistribute the pie? How are we going to cut the pie slitter and thinner and thinner? My attitude is get a bigger pie. And where does that bigger pie come from? Well, yeah, tax credits, yeah, entrepreneurship, yeah, all that. But it mainly comes from invention, science. That's where the pie gets bigger.
Michio Kaku, where were you born? You were born in 1947. Where were you born and raised? Who were your parents?
Well, first of all, my grandparents came from Japan about 100 years ago. In fact, my grandfather was in the 1906 San Francisco earthquake and helped with the cleanup operation. My parents actually grew up in Japan. They were born in America, grew up in Japan, which is common for immigrants. And then they came back to America right before World War II, which was the wrong time to come back to America. They were placed in a relocation camp from 1942 to 1946. They met at camp, got married at camp, and I was born soon after the camp opened up. But for 4 years, they lived behind machine guns and barbed wire.
So you were born in camp, in an
I was
internment
born
camp.
right after camp. My older brother was actually born in camp. And then myself and my younger brother were born after the camps opened up in 1946. And I knew even as a kid that if science was going to change society, how can a poor little kid with poverty-stricken parents ever have a chance of making it in society? So when I was in high school, I realized that I had to seize my own destiny. So I went to my mother one day and I said, Mom, can I have permission to build an atom smasher in the garage? A 2.3 million electron volt betatron electron particle accelerator. And she said, sure, why not? And don't forget to take out the garbage. Well, I took out the garbage. I went to Westinghouse, Baring Associates. I got 400 pounds of transformer steel, 22 miles of copper wire. And I created a 2.3 million electron volt betatron in my garage. It consumed so much power that I blew out every single circuit breaker in the house. My poor mom, she'd come back late from work, the lights would be flickering and die. And she'd say, where's the fuse box? And then she must have said to herself, why can't my son play basketball? Why can't he play football? Why can't he find a nice Japanese girlfriend? I mean, why does he have to build these machines in the garage? Well, that machine helped to get me into Harvard. So I can't begrudge the benefits of building atom smashers for your science fair project. But because I built that machine, I earned the attention of an atomic physicist who immediately knew what I was doing. I was working with antimatter. He saw my experiment and he knew exactly what I was doing. No explanation or whatever. That scientist was Edward Teller, the father of the hydrogen bomb. Took an interest in me. He funded my 4 years at Harvard University. So that set me off. However, after I graduated from Harvard, he wanted to know, in fact, he really pushed for me to go into weapons work, to design hydrogen warheads, hydrogen bombs. Physicists do work on these things. Even today, some of my colleagues work on hydrogen warheads. However, I did not want to go that way. I wanted to work on an even bigger explosion than a hydrogen bomb. I wanted to work on the creation of the universe. I wanted to know why the laws of motion and the laws of the universe are the way they are at the instant of the Big Bang. So I went on a different route.
Dr. Kaku, have you been given government grants?
Yes, my PhD was paid for by the Air Force, and the National Science Foundation does pay for our physics department's research. So the answer is yes. The government does support science, which I think is a good thing. However, I think the support is minimal compared to a few battleships and a few of the latest inventions of the Pentagon. But yeah, we do depend upon government support.
What kind of work did your parents do?
My father was a gardener. After World War II, it was very hard to get a job. There was a lot of anti-Japanese sentiment. But in the Bay Area, where my parents settled, there was a need for gardeners. And my mother was a maid, and they would dream about sending their kids to college.
Next call for Michio Kaku comes from Boston. Bruce, hi.
Thank you for taking my call. I've very recently just gotten into astronomy, and I enjoy you on the Science Channel very much. I have one question about Mercury and one question about Jupiter.
Sure.
I don't think it was on your program, but I saw on TV that Mercury has a double sunrise, and I thought that's fascinating. If you could talk about that. And they only recently agreed on a formal definition for what a dead planet is. Do you think Mercury is a dead planet because there's no life, and because there's no activity at its core? And do you think that is it true that Jupiter was almost a star like our sun, but there wasn't quite enough heat and pressure at the core to kickstart the nuclear fusion process?
All right, Bruce, we got 3 questions there.
Okay,
Jupiter
right.
and Mercury.
Okay, let's take it one at a time. First of all, if you take a look at Mercury, Mercury we think is a dead planet because it's simply too close to the sun, it's boiling hot. Water would simply turn to steam and eventually maybe even break apart. You have to be what is called in the Goldilocks zone from the sun, not too close where water turns to steam, not too far where liquid water turns to ice, but just right from the sun so that you have liquid water. Liquid water is the universal solvent. It's where DNA got off the ground. So we think that planets in the Goldilocks zone can be, in fact, the potential creator of life forms. Just last week, it was announced by astronomers that they have finally found such a planet, a twin of the Earth. It's maybe three or four times more massive than the Earth, but it is smack in the middle of the Goldilocks zone. And that changes everything, because it means it may have liquid oceans. It means it may have DNA. We don't know for sure. But this is a game changer, and it only happened just last week. Mercury, on the other hand, is too close to the sun, and as a consequence, we think it's unsuitable for life. Farther out, we have the gas giants like Jupiter, where we don't think we have enough liquid water, except maybe on Europa, a moon of Jupiter. That has an ocean, we think, under the ice cover. So there are 2 places in the universe where we could have liquid oceans. One, in the Goldilocks zone, like the Earth, and second of all, under the ice cover of Europa. Last question was about Jupiter. Is it possible that Jupiter can ignite into becoming a star? If you saw the movie 2010, a sequel to the movie 2001, at the end of the movie, the aliens ignite Jupiter, and we become a double star system. Well, it's not going to happen. Jupiter is about 10 times or so too small. However, if Jupiter were more massive, perhaps around 10 times larger, then the answer is yes, we would have been in a double star system. And again, most of the star systems we see in space are double star systems. Our solar system is rather strange. We have a single star with planets going around it, while most stars are part of a double star and even a triple star system.
Michio Kaku, let's go back to the parallel Earth that was recently discovered. How was it discovered? Is this a huge deal? How far away is it, et cetera, et cetera?
Well, detectives say follow the money. Astronomers say follow the water, because where there is liquid water, there could be life. And that's the game changer that took place just last week. This is the holy grail of planet finders, that is, finding an Earth-like planet in the Goldilocks zone. This planet is 20 light years away from the Earth. It's about 120 trillion miles away from us. So a Saturn rocket would take tens of thousands of years to reach that planet. So don't think we're going to find anything soon or visit that planet anytime soon. However, it's part of a 6-planet system. A red dwarf with 6 planets going around it. One of these planets is the Gliese 581g, the planet that was just identified. Size-wise, it's about 20% larger than the Earth, size-wise, but mass-wise is about 3 to 4 times larger than the Earth. But the important thing is that it's smack in the middle of the Goldilocks zone. We hit the jackpot on this one. And remember that we're now going to find hundreds of these Earth-like twins. We have the Kepler and the Kourou satellites in orbit, 2 satellites, one American, one French. They are specifically designed to find hundreds of Earth-like twins in outer space. So one night, when you look at the night sky, you will say, there are Earth-like twins, and you will wonder whether anyone is looking back at us.
Doctor, do you think at some point we'll think, I don't know why we chased water? What's the importance of water?
Well, well, first of all, water dissolves most materials. It's the universal solvent. It does not dissolve certain oils or certain minerals, but many chemicals are dissolvable in water, including hydrocarbons like amino acids and proteins, and most important, DNA. DNA is important because it can make a copy of itself. Starting with one DNA molecule, you get 2, then 4, then 8, 16, 32, 164, 256, and then you have life taking over an entire planet. That's why we say follow the water. And on Jupiter, a moon of Jupiter, underneath the ice core, we have Europa with a liquid ocean underneath, whose volume may actually be bigger than the volume of our oceans, because our oceans are very thin. The oceans of Europa could be very deep. NASA wants to send a submarine. NASA has plans to send a submarine drilling right through the ice cover and then swimming underwater. And we think that Europas could be much more common than Earths in outer space. Now, you ask how we detect them. If a planet goes around the mother star, they actually orbit around a center of gravity like a spinning dumbbell. Now, you remove the planet, because you can't see the planet, and the sun wobbles. So it's the wobbling of the mother star that we look for, because the whole system cannot be observed by telescope. That's how we found this planet in space.
This is Book TV's In Depth, and our guest this month is Dr. Michio Kaku, who is a theoretical physicist, teaches at City College of New York, has been teaching there for the last 25 years, hosts a program on the Science Channel, hosts a couple of radio science programs, and is taking your calls. Winter Park, Colorado, go ahead with your question.
Hello, how you doing, sir?
Very good.
It's a real, privilege to, speak with you. I was dying to have a chance to ask this, question. I follow you on the radio. I have a two-part question, and it's a very raw and simple in part. The first part of the question is it possible, in the view of the scientist, to build a vehicle that will travel faster than the speed of planet Earth, and it will orbit Earth, the opposite to its own movement, in order to bring an object 24 hours back to where it was. And the second part of my question, looking at the history of Earth and different theories where the scientists say that the planet Earth was going through different cycles of life and different, degrees of human, wisdom, is it possible that we are, as in our present time, one of the, cycles or one of the, levels? And
all right, we're going to, we're going to have to leave it there. I think Dr. Kaku knows what you're looking at.
Okay, you talk about how fast our rockets go, and can our rockets actually synchronize themselves with regards to the planet Earth and even move faster than the planet Earth? And the answer is yes. A typical rocket travels at 18,000 miles per hour. That's the orbiting velocity sufficient to go around the planet Earth. And our rockets can actually go faster than that, 25,000 miles per hour. That is enough to take you to the moon. In fact, it was Isaac Newton who was, in principle, the first man capable of calculating what it would take to jump to the moon. If you can run 25,000 miles per hour and jump, you too could jump all the way to the moon. And then, to answer your question about synchronizing with regards to the Earth, we also have satellites that are geosynchronous. They go around the Earth in 24 hours. The Earth itself spins in 24 hours. Therefore, we have the illusion that the geosynchronous satellite is actually stationary. So when you plant your TV dish and you lock onto a satellite, that satellite doesn't fall down. It's actually spinning around the Earth, but at a very large distance, about 22,000 miles. So given the fact that our missiles and our rockets can travel, let's say, up to 30,000 miles without too much effort, it means that, yes, we can definitely synchronize ourselves with regards to the Earth and its planetary motion.
Greensboro, North Carolina. Hi, Lori.
Yes, hi, how are you?
Good.
Hi, Dr. Kaku. I have a question about emotional vibration or energy in motion. And it stems from a person I know, Riley Martin, and he wrote the book Coming of Tan, and he notes that beings whose home planet is not Earth, that they're actually intrigued by the emotional energy of humans and humans' ability to feel and emote and vibrate that energy with love and heart. So my question was, how and what do you feel about emotional vibration, that energy, and its impact on humanity's consciousness, the planet's vibrational field, and the multiverse's vibrational field?
Okay, you ask an awful lot, so let's try to break it down one by one. First, you talk about vibrations. Everything is vibrating? The answer is yes. Everything is governed by tiny little waves. We have equations for these waves given by Erwin Schrödinger in 1925, and that's the beginning of wave mechanics, out of which transistors, lasers, GPS systems, satellite operate. So first, everything is vibrating, just like what people say. Second, there is such a thing as emotional energy, and scientists are now beginning to appreciate more and more the power of this emotional energy. While before we would say, ha, humbug, that's like soft-headed science. Now people are realizing that it's very important for us to communicate for our well-being. Emotions affect the body in ways that we are just now appreciating. And also, if you watch science fiction now, you watch Star Trek and we have Data. Data, the robot, has no emotions. And we say to ourselves, well, gee, emotions must be a very high form of intelligence. Well, now we realize how important emotions are. A stroke victim, for example, will sometimes have the front part of their reasoning brain disconnect from the center part of their brain, which governs emotions. The center part of our brain, the limbic system, is the emotional brain. The front part is the cerebral cortex, the thinking part of the brain. Stroke victims, accident victims, sometimes the connection is broken. So what happens when people have reasoning ability but no emotional control? What happens is, and this shocked scientists when it was analyzed, these people have problems making decisions. They're paralyzed because value judgments, what's important, what's not important, what is precious, what is not precious, what is irrelevant, it's all the same to them. When they go shopping, they're paralyzed because everything's the same to them. What's important, what's not important. And so now we begin to realize why emotions are important for our own evolution. We would be paralyzed. We wouldn't know what's important, what do we have to do. Everything's the same. So emotions give us an emotional value judgment on certain kinds of behaviors. That's how we decide what is important, what is not important, what is precious, what is not precious. And that's why Data and Spock on Star Trek, they're making emotional judgments all the time, even though they're supposed to be not emotional. They made the decision to join Starfleet. They made the decision to do this, to do this. All of them are value judgments. So scientists now are beginning to appreciate the importance of emotions in designing artificial intelligence. It's part and parcel of that. But as far as energy fields and stuff like that go, we think the brain does emit energy, and this energy is electromagnetic, and you can measure this with EEG scans, MRI scans. But you cannot manipulate objects without external intervention. We can now, quote, read these emotions with MRI machines and EEG machines, but it takes machines to do this. With brain waves, we can now actually tell what you are thinking about to a degree. This is a fast-moving field. It's called mental imaging. We're now capable of actually imaging some emotions of the brain using our instruments. But again, this is a frontier area, and it's an area that is not explored very much at all, because scientists historically would poo-poo this whole area, which we now know to be very essential to creating intelligent people.
And in Physics of the Impossible, you write about these things, and you write about categories of impossible technologies. Class 1, those that are impossible today but do not violate the known laws of physics. Class 2, those that sit at the very edge of our understanding of the physical world. If they are possible at all, they might be realized thousands to millions of years in the future. And Class 3, those that violate the known laws of physics. Is there any technology today that exists that's now used to be Class 3?
Take a look at invisibility. I used to teach in my optics course that objects cannot be made invisible because the index of refraction is always less than 1. We would write that equation on the blackboard, say QED, ergo, no such thing as invisibility. Well, we were wrong. I was wrong. Every single optics textbook on the planet Earth is wrong in saying that invisibility is a class 3 impossibility. Just 3 years ago, we did it with microwave radiation. It turns out that you can build a cylinder like a Harry Potter cloak. Microwaves will hit the cylinder, wrap around the cylinder, come out the other end as if you are not there at all. With light, we think you can also do it with light beams now. In Germany, they actually made a small particle disappear optically. So in the future, we may have an invisibility cloak. Light will come at you, light will bend around Harry Potter, reform on the other side of Harry Potter, and Harry Potter inside this cloak becomes invisible. Just like a boulder in a stream. If you're downstream of a boulder, you don't know there's a boulder upstream because water wrapped around the boulder and reformed. Well, we've done it in the laboratory. The index of refraction can actually be negative. We never thought that was possible because there was a loophole in the laws of optics. We always assumed that materials like glass are uniform. Once you make them highly non-uniform, you create what are called metamaterials, and bingo, objects can become invisible. So something that was class 3 now becomes something called class 1.
Dr. Kaku, email from Terry Nichols, Glastonbury, Connecticut. One often sees photographs of theoretical physicists standing at blackboards filled with mathematical characters. Is math the only language through which the complexities of physical reality can be expressed?
Yes and no. First of all, when we physicists talk to each other and write papers, it is in the language of mathematics. However, beyond the math is the physical picture. It is the picture that makes everything move. My favorite Einstein quote is, quote, "If a theory cannot be explained to a child, then the theory is probably worthless." Meaning that all great theories are explained pictorially. Newton thought about apples and balls going around other balls. Einstein thought about trains and rockets and clocks and meter sticks. String theory talks about little tiny vibrating rubber bands. All these things are pictorial, things that children can understand. I've noticed that some scientists who are not so good get trapped in the thicket of mathematics. They get mired down in the quicksand of all this algebra and they lost the picture. That, unfortunately, is what happened to Einstein in the last 30 years of his life. He was onto an idea, but there was no picture there. So he worked on the unified field theory for 30 years, but there was no guiding light. He was looking for, he wrote the fact that I have no guiding principle. I know the destination is unification, but there's no shining light that led him to relativity, no shining light to the unified field theory. So math is important. But what's more important than the math is the physical picture behind the mathematics. Now, the other thing is, yeah, you have to have mathematics. It's like trying to learn French civilization without learning the French language. Sure, you can get a comic book understanding of French history and the French character, but to really understand the French civilization, you have to learn French. So that's something that is essential. You do have to pay your dues. You have to learn the math.
Next call for Dr. Kaku comes from New Mexico. Christmas, New Mexico, Ryan. Hi.
Hello, yes, thank you, Doctor. It's good to talk to you. Calling from Las Cruces, New Mexico. I was a New Mexico State University physics major, but then I left to the Navy and I came back, and now I'm returning back to school. And you may have heard of Sandia Lab and Los Alamos Lab. They're known for New Mexico and the birthplace, I believe, of the atomic bomb. I know we're time limited, so I'm just going to get to the point. If you could do it all over again, you go back to school, would you have gotten a math degree? You know, we notice that math is very, the language of science, but they talk about complex analysis, they talk about number theory, and it's used in physics and chemistry. But would you go back and do math instead of physics?
When I was undergraduate at Harvard, I was looking into different things, like maybe even philosophy or mathematics, but I began to realize something that was very unsatisfying. And that is that in mathematics, you could get lost because there's no guiding principle. There's no physical hint. There's no application. And as a consequence, you can spend all your time doing proof theory or going around in circles and not being relevant to anything at all. You spend all your time trying to prove theorems which are kind of obvious but are very difficult to prove. Arthur Eddington, the great cosmologist, once said that mathematicians engage in self-flagellation at the altar of proof. Now think about that. Here's an altar, there's proof. You want to prove this theorem, and you spend the rest of your life flagellating yourself trying to prove this obscure theorem that no one cares about. I said to myself, that's not for me. I want to explain creation, Genesis, the way the universe evolved, the superforce that drives everything forward. So I took a course in philosophy. I thought maybe in philosophy we'll have deeper understanding of the nature of reality. Well, we spent like one whole semester on Aristotle, learning things that are totally of no relevance at all. I read the Nicomachean Ethics about what is the good, and after reading this gigantic textbook written by Aristotle 2,000 years ago, the good turned out to be the mean. Not too close, not too far. The mean, that is the good. So I began to realize that there was something unsatisfying in philosophy, that it was detached from reality. And Einstein even said that philosophy is like honey. It looks good, it smells good, but after you touch it, you realize that it's all gooey and messy and not really relevant at all. In physics, I saw things that are fundamental to reality. And being a physicist, I understand how DNA works. I understand how computer architectures might work. I can begin to understand other areas of science, because physics is the foundation of all science. And so being a physicist is very easy for me to look into other areas outside physics, which are byproducts of physics. The DNA molecule was unraveled by physicists. Francis Crick was a physicist. Delbruck, many of the early pioneers in DNA research, they were all physicists. People working in artificial intelligence theory, many of them are physicists. And if you take a look at the great inventions of the world, they're all invented by physicists. Lasers, television, radio, microwaves, MRI scans, PET scans, you name it. Some physicists created it. And so I said to myself, that's for me.
Rick, Flagstaff, Arizona. Rick, Flagstaff, Arizona.
Konnichiwa, Professor. Greetings from 7,000 feet high, beautiful Flagstaff, Arizona. How are you today?
Very good.
I have a question about time travel for you. First of all, I'm wondering about time travel into the future. Secondly, I'm wondering about, and I know you've heard this, but not everyone has, what happens if I love evil and I find out that somebody really evil died of a certain condition, then I go back into the past and save them from that condition. What's to stop me from starting a race of super evil people?
Okay, well, let's get right into it. First, it is possible to time travel into the future. We do this all the time with our particle accelerators. As you go toward the speed of light, time slows down with regards to somebody on the planet Earth. So you are going into the future as a consequence. When you go to the nearest star, it's 4 light years away. If you could go very, very fast, you might be able to get there in your own rocket in 4 seconds. On Earth, it took 4 years for you to make that trip. But in your rocket, it appeared as if you only spent 4 seconds going to the nearby stars, traveling near the speed of light. So you went into the future. In fact, on the moon beats faster than the Earth. Clocks on the moon beat faster than clocks on the Earth. Clocks on Jupiter beat slower than clocks on the Earth. So simply by going to Jupiter, you already go a few microseconds into the future. So future travel is not the problem. We do it all the time with our rockets. Going to the past, that creates a problem. Because what happens if you go back into the past and meet your teenage mother before you're born? If your teenage mother falls in love with you, you're in deep doo-doo, as Michael J. Fox found out. Now, the way we resolve these paradoxes of going to the past is simple. Newton thought that time was like a river, this gigantic flowing river that never speeded up or slowed down. Einstein comes along and says, not so fast. This river is a meandering river. It speeds up and slows down. We measure this every day with our satellites. The new wrinkle on all this, causing all the excitement, is the fact that this river of time can have whirlpools. The river of time may fork into two rivers. Now, if the river of time forks into two rivers, then there's no paradox of killing your parents before you're born. You cannot commit suicide in the past, for example, because you simply hop stream. You go from one fork to the other side of the fork. So when you go backwards in the past, meet your teenage mother before you're born, she's not really your teenage mother. She looks like your teenage mother. She has the same genes as your teenage mother, but she's a parallel teenage mother. So you cannot save Abraham Lincoln from being assassinated at the Ford Theater. You cannot change the past. That's if the river of time forks. If the river of time has whirlpools, then yeah, you might have problems. Then you might be able to commit suicide in the past. And if you can have whirlpools, you can even become your own mother and your own father, your own son and your own daughter. How do you do that? If you're a woman and you go back, you go into the future, turn into a man, go back into the past and meet yourself as a young girl, date yourself, and have children, you basically can become your own mother and your own father. So whirlpools in time do involve paradoxes. If the river of time forks into two rivers, which is what the quantum theory says, there are no paradoxes whatsoever.
This is Book TV's In Depth. Our guest is physicist Michio Kaku. We have an hour and a half left with our guest. Here are his books. 1995, Beyond Einstein. Also in 1995, Hyperspace came out. And then in 1999, Visions, How Science Will Revolutionize the 21st Century and Beyond. Einstein's Cosmos came out in 2005. Parallel Worlds came out in 2006. And Physics of the Impossible is his most recent, came out in 2008. You're currently working on a book?
That's right, coming March. I'll be coming out with Physics of the Future. I'll be projecting the year 2100. This is perhaps one of my most ambitious books. I've interviewed over 300 of the world's top scientists about the future, and I've compiled all their thoughts into a coherent picture of what the year 2100 will look like. What kinds of gadgets will we have? How will we communicate? What will computers look like? What will medicine look like? I look into the question of immortality, robots, the internet, what these things will look like in the year 2100. That's coming out in March.
And again, an hour and a half left with our guest, Dr. Kaku. We visited his office at City College in New York to see how he wrote. Here it is.
Hi, I'm Dr. Michio Kaku. I'm a professor of theoretical physics here at the City College of New York, which is part of the City University of New York, and this is where it all happens, right here at the college in Manhattan. First, you have to know what you want to write about. That's the most important thing about a book. You have to have the kernel, the idea, as clear as possible in your mind. Then you type up a proposal and you send it off to an editor at a big publishing house. Assuming it gets accepted, then the process is you have to do research. And over there you can see piles and piles of research notes that I get to make sure that everything is accurate. So you spend literally months at a time going through all the literature, going through the books, going to libraries, going to the web to make sure that your information is authentic. Then you have to write the manuscript. And this is what a typical manuscript will look like. We're talking about a manuscript here that runs about 500 pages, double-spaced, and this is basically the book. Writing a book is almost like giving birth to a baby. You have to do draft after draft after draft to get it exactly right. You have to look at the same sentence over and over again to make sure it's perfect. And so the number of drafts you go through, if you were to stack it up, would be about this tall. So that's the total number of drafts that you would have to go through before you finally get the book. You just can't do it on the first try. It's a process of polishing and polishing till you get it just right. And science books are different from novels. In novels you have to worry about dialogue and action and pacing. For science books you have to be very careful. Because on one hand, I'm a scientist, I know the science, it's like the back of my hand. However, the problem is to make it understandable to the average person. And so I begin to realize that when I have to take a theory and explain it to a high school kid, then I begin to realize that I don't understand the theory all that well. I begin to realize the problem is not the high school kid, the problem is me. I have to understand it backwards and forwards so that I can communicate it to somebody with no science background whatsoever. When I'm working on this manuscript, basically most of the time I'm just thinking by myself. I have the chapters in my head, I have the sequence of ideas in each paragraph laid out in my mind, but the order's not right. So I begin to play with things in my mind. Once I sort of understand the order of which things happen, then I can simply go to the word processor and punch it out. Then you give it to the editor, who will then approve it or not, make changes, and then comes back the galleys. And this is what the galleys look like. They're all typeset. Everything is computerized these days. And it runs also roughly 500 pages. So these are the galleys, and then you can make final changes in this copy. Then finally, the book itself comes out. And when the book comes out, it comes out in different languages as well. My books are translated all over the world in different languages, Chinese, Korean. This, for example, is the Portuguese edition of Parallel Worlds. And I know where my books are published because people send me emails from all over the world. You have to depend on the translator to do an honest translation. Unfortunately, when my book was translated into Japanese, the translator thought he knew more than I did. And he started to inject his own personal comments and commentary. This is the worst nightmare you can possibly imagine, writing a science book where the translator thinks he knows more about the subject than you do and starts to interject his own point of view. Well, the book was published, it got right by the editor, and of course the publisher and the editor had to apologize to me later. The relationship with the editor is very important because sometimes you could be going off in a tangent, in the wrong direction. And so what the editor does is, first of all, he puts you on the right track so you know exactly where you are reaching. You know where you're going to begin, you know where the end point is, and then the editor can map out where he thinks perhaps the book begins to deviate. Also, the editor is a non-scientist, which is very important because you want a non-scientist to be able to experience the thrill of science in the making and to understand why it is so relevant. So if your editor can't understand it, no one can understand it, and it means you have to go back to the drawing board. On Tuesdays, I put on a microphone and I'm talking to 130 radio stations around the country that carry Science Fantastic.
What kind of classes do you teach now?
Right now I teach astronomy. Sometimes I teach in the graduate program. I teach grad students. We're in the planetarium of the City College of New York. In fact, it's the second largest planetarium in Manhattan, second only to the famous Hayden Planetarium at the American Museum of Natural History. Here, however, we can seat about 50 students, and we give planetarium shows because we want kids to be fascinated about the universe they live in, because it's their world. This is the universe they live in. And with the planetarium, we can recreate the stars, recreate the planets and the galaxies. We give regular planetarium shows to our kids. We talk about the space program, the exploration of the planet, stars, and galaxies. But my course has 300 kids, so you can't put 300 kids here. It's too small. So we have planetarium shows here where we try to take local kids from the neighborhood and show them that there's a huge universe out there. You know, so often, kids never look up. I tell the kids, look up. Some kids spend all their life looking at the ground. Look up. Look at the stars. See where you come from. See where you are with respect to this great universe of ours.
We are back live with Dr. Michio Kaku, physicist and author, talking with him on Book TV's In-Depth program. We'll put the numbers back up on the screen in case you'd like to call in and talk with him. 202 is the area code. 737-0001 for those in the East and Central time zones, 737-0002, Mountain and Pacific time zones. Email at booktv@cspan.org. I should tell you, though, we've got stacks of email right now, and I'm not sure we're going to be able to get through a tenth of what we've got. So it might be a little late to get in. Dr. Kaku, why Isaac Asimov?
Isaac Asimov is one of my favorite science fiction writers because he blew my mind away when I was a teenager. Usually in science fiction, it's science opera, space opera. You go to outer space, shoot up the aliens, get the girl, and end of story. That's it, right? Well, when I read the Foundation series, I said to myself one word: wow! You are now tens of thousands of years in the future, where humanity has colonized not just a few nearby stars, but so much of the galaxy that humanity has forgotten where the Earth is. Earth itself is somewhere in the backwash of ancient history, and the empire is dying. This galactic empire is dying. And then there was an attempt by some of the scientists there to predict the future, to use mathematics to predict the sequence of events into the future. So I said to myself, wow, I mean, think about this. A galactic civilization, civilizations that have spread across the galaxy, using the power of mathematics to predict what inventions, what political developments, how human behavior will evolve, because there's so many of us. Trillions of us. You can predict the behavior of trillions of atoms. You cannot predict the behavior of 5 atoms, but you can very well predict the behavior of trillions of atoms. So he applied that basic philosophy to humankind itself. Now, that was also important for me, because so many of my colleagues laugh when they think about intelligent life in outer space. They say, ha, ha, ha. How can they possibly reach the Earth? Stars are so far away. But that assumes that alien life in space is only 100 years ahead of us. Then you're right. You have every right to laugh and snicker, because intelligent beings 100 years from now are not going to be able to go rocketing across the star systems. However, now imagine a civilization 1,000 years ahead of us, 1,000,000 years ahead of us. That's just a blink of an eye with regards to the age of the universe, which is 13.7 billion years. Then new laws of physics begin to open up, new possibilities. So we can't simply laugh at other people's opinions about intelligent life in outer space, because you cannot assume that intelligent life in outer space is only 100 years ahead of us. That's a type 1 civilization. What happens if they're type 3? Galactic, maybe 100,000 years ahead of us. And that's why I think that we scientists have to keep an open mind. And now, of course, we are finding evidence of planets out there in outer space that are just like the Earth. And one day, maybe we'll make contact with one of them.
Why is the speed of light the limit? Is it because we can't detect anything faster? That's Michael Glenn O'Grady in Encinitas, California.
Well, if I knew the answer to that, I would get a whole shelf full of Nobel Prizes. It's one of the basic laws of the universe. The speed of light is a constant in all inertial frames. Whether light comes toward you or whether light is moving away from you, it always travels at the same velocity. Now that violates common sense. If a rock goes toward you, away from you at different angles, rocks travel different velocities with regards to where you are. But no matter how you measure a light beam, it's always traveling at the same speed of light. That means that space and time have to be distorted so that the speed of light is a constant in all inertial frames. Now, why? Why is that true? Why is Einstein the cop on the block saying you cannot break the light barrier? And the basic answer is we don't know. It's just one of the big laws of the universe. Now, Einstein was led to this, by the way, when he was 16 years old. When he was 16 years old, he had a thought experiment. If you're racing alongside a light beam, the light beam should be stationary. Just like when you race next to a speeding car, you can look at the driver, wave to the driver as if you're neck and neck and you're stationary. So he thought to himself when he was 16, if you're racing a light beam, the light beam should be frozen. It should be at rest. But frozen light, he said to himself, doesn't exist. No one has ever seen frozen light before. Therefore, you cannot race faster than light because there's no such thing as stationary light beams. Well, he was right on the mark. When he was 26 years old, 10 years later, he finally learned the mathematics of James Clerk Maxwell, which allowed him to solve the problem once and for all. Why is it true? We don't really know. It's just one of the fundamental laws of the universe.
Dr. Cuthbert Simpkins emails in, isn't time an artifact? Isn't the harmonic oscillator a misleading model even though it gives correct answers?
Well, I get emails sometimes from people who say that time is a fiction. Time doesn't exist. It's an illusion. Well, maybe, but without time, there's no change. Everything changes in our world. So if time didn't exist, nothing would change. So there would be no world as we know it. Now, the progression of time can play tricks on you. For example, I host specials for BBC television sometime, and we all have the illusion that in a car accident, time slows down. So we did an experiment. We got this guy, gave him a stopwatch and a camera, and we pushed him backwards off a tower. Now, if you're pushed backwards off a tower, you go screaming because you think you're going to die. Well, we had him look at images flashed at him. These images flash so fast that the ordinary eye can't see it, like a number flashed at him. When we pushed him backwards, he saw the number because time slowed down as you're falling backwards. So you can actually measure this effect, measure the effect that the progression of time slows down when you're frightened, when you're in a panic mode. The progression of time does change. That doesn't mean that time has changed. It just means that your neural circuits speed up, so you process information faster. You can see numbers which flash across the screen, which normally are too fleeting to be seen.
Next call for Dr. Michio Kaku comes from New York City. David, hi.
Hi. I don't know if anyone has said this to you, Peter, but you've been doing in-depth now for I don't know how long, but I know you're doing a great job, and I think someone should say it to you, so I'm saying it.
Okay.
As far as the professor goes, I happen to teach psychology at CUNY, what used to be downtown city, Baruch College. My name is David Chowes, and I agree with you. You mentioned at the end of the Cold War, and that has slowed down what's being found in or has lowered the amount of funds given to scientists. I think that's true, and I think a bigger problem is the fact that people who are exposed to science, whether it be in junior, senior, high school, or in college, are taught the applied facts of science, but they are not. There is no emphasis on what science is. Very briefly, I'll ask you a second question. They talk about alternative science, especially alternative medicine and therapies. They're really not, I'm asking you, it's not really science. It's not science until it's validated to a particular probability. Would you please comment?
Well, you ask about the philosophy of science, so let's try to, break it down. The way science is taught, there are many ways of approaching the way science is taught, but I think science is taught the wrong way. First of all, we are all born scientists. We're born that way. We're born wondering why the sun shines, where we came from, where did the earth come from. We're born that way. Then we hit high school, and then it's crushed out of us. Any germ of curiosity comes up against this huge barrier as we begin to study exams and learn rote memorization, learn the parts of a body and the flower. And it's a miracle that any of us can survive that process, because that's the way science is taught. Science is taught as basic memorization. For example, Richard Feynman, the Nobel laureate, when he was growing up as a child in Queens, he tells this story. his father would take him into the forest, and the father would point out birds to him and explain why the coloration was the way it is, the shape of the beak, the way they flew, their mating habits, all the behaviors and the physical characteristics of birds explained by the father. Then one day a bully comes up to the future Nobel laureate and says, "Hey Dick, what's the name of that bird over there?" And then the young Feynman realized that, hey, he could tell the bully everything about that bird except one thing, its name. So he said, "Well, I don't know." And then the bully said, "What's the matter, Dick? You stupid or something?" And in that instant, he suddenly realized the difference between the appearance of science and real science. The appearance of science is giving names to things, learned names for simple objects, but that's not science. Science explains where it came from, how it evolved, why it is the way it is, and that's not the way we teach science. And as a consequence, I think it's no wonder that so many of our kids realize that this is boring stuff. It's stuff they have to learn, but it's stuff that really is of no relevance to their lives, which I think is really a problem. And then you mentioned the Cold War. Yes, during the Cold War, scientists did benefit. And in fact, Sputnik of 1957, I still remember the shock waves that went out when Sputnik went up in orbit. It was your patriotic duty to become a scientist, an engineer, or what have you. It was your duty because America was being threatened by the Russians. People thought that hydrogen bombs would be raining from outer space with Sputnik. So it was glamorous. It was the thing to do. Now, it's all gone. There's no sense of urgency. And our competitors, however, they know their meal ticket is going to be science and technology. They're not stupid. They're sending their finest minds to America to learn science. We benefit from that. But then now China wants them back. And China is luring them back by promising them being head of industry and being heads of laboratories. So our scientific establishment is under threat. It's under threat, not under the attack of the Russians. It's under threat by our complacency, that we don't understand why we have all this riches and all this riches of technology. It's because of science. It could just as easily dissipate as well as come.
When you wrote Visions in the 1990s, it got a New York Times, it was reviewed in the New York Times and considered by one reviewer as infotainment. Has it held up in what you predict?
Yeah, I predicted out to the next 20, 30 years, and we're right on schedule. Read that book. What will a computer look like? What will medicine, what are the breakthroughs going to be? And then people come and ask me, how come your book predicted it right on the button, year by year, decade by decade? And the answer is, I cheated. I get to interview all the leading scientists. My radio show goes out to 130 radio stations across the United States. I do things for BBC, Discovery Channel, Science Channel. I get to take a film crew right into the laboratory and show the advances in DNA, show the advances in computer technologies and lasers that are going to change our world. I get a front row seat to see the future. So I know these technologies are going to ripple through because A, they already exist. B, some of the finest minds are pushing it, and C, it's only a matter of time before somebody commercializes these technologies. And now my next book, as I mentioned, Physics of the Future, will be even more ambitious, talking about the next 100 years. Now, some people say you can't go that far. But remember that Jules Verne in 1860, when Abraham Lincoln was mired in the Civil War and we had horse-drawn carriages, realized that Jules Verne predicted Paris in the year 1960. And Jules Verne, during the time of the American Civil War, predicted that we would have glass skyscrapers, gas-fired engines, something that looks like a fax machine, something that looks like the internet. He was right on the button. And how did he do it? Well, the same methodology I use. Jules Verne picked the brains of some of the finest technologists, engineers, and scientists of his time. That's as close as you can get to the future.
And in Visions, a consensus is growing among America's top computer experts. Computers will become so small and ubiquitous that they will be invisible everywhere and nowhere, so powerful that they will disappear from view. Next call for Dr. Michio Kaku comes from Manhattan. Go ahead, Christine.
Hello, Dr. Kaku. It's such an honor to speak with you.
Thank
I have
you.
a few questions for you about aliens.
Mm-hmm.
If aliens were to come to Earth with hostile intentions, do you believe it's possible there could be both good and bad aliens, and the good ones would possibly help to protect us? And also, I read in the Financial Times a couple of years ago that Stephen Hawking said Earth might become uninhabitable in about 40 years. Could aliens have anything to do with this possibility? And finally, what is your general opinion of aliens and their interaction with us? Do you believe they could in some way already be here?
You ask a lot of very interesting questions. First of all, why don't they simply land on the White House lawn? Why don't the aliens simply have flying saucers, land on the White House lawn, and greet the President of the United States? Well, you have to look at it this way. If they can reach the Earth from a distant star system, they are thousands of years ahead of us in technology. And if you're walking down a country road and meet an anthill, do you go down to the ants and say, I bring you trinkets, I bring you beads, I give you nuclear energy, take me to your Ant Queen? Or perhaps you walk away or maybe even step on a few of them. So remember that if they're that advanced, they've already been watching us. They've already been looking at where we are. They don't have to land on the White House lawn. They don't have to prove anything. Also, if you're a deer in the forest, who do you fear the most, the developer or the hunter? Well, you may say to yourself, the hunter is dangerous. The hunter can kill the deer. The hunter wants to kill the deer. The hunter wants to eat the deer. But if you think about it, the real danger is the developer. Because the developer couldn't care less about the deer. The developer just wants to pave the forest over, and of course all the forest creatures are going to die because their habitat has been paved over. So I think that if we do meet alien civilizations from outer space, first of all, A, they're not going to be hostile because they'll have had thousands of years to work out their sectarian, religious, fundamentalist, racial problems. B, they'll have plenty of deserted planets to plunder. They don't have to land on the Earth. They can land on Mars and uninhabited planets where they have minerals and different kinds of raw materials. But C, if they do come to the Earth, they're not going to land on the White House lawn. What they'll do is they'll send robotic probes throughout the galaxy. How many planets are there that can sustain life? Perhaps billions of planets in our own galaxy. To explore the galaxy, what you do is you send a robotic probe, lands on a moon, because moons are stable, and it creates a factory that creates copies of itself, 1,000. And then maybe 1,000 robots fly out to 1,000 moons. Each one creates 1,000 more robots. So starting one robot, you get 1,000, then 1,000,000, then 1,000,000,000, trillion, quadrillion, and pretty soon you populate the entire galaxy. Where have you seen that before? You've seen that before twice. First, in the movie 2001. Perhaps they're already here. Perhaps they're on our moon, and we are too primitive to have a moon base to detect it. So the movie 2001 should have been called 2100, when we do have an operating moon base that can detect a probe left over from an ancient civilization maybe millions of years ago. And where else have you seen this? In a virus. That's how viruses colonize your body. Our body consists of about 50 trillion cells. How is it that one molecule can colonize your lungs and make you sneeze? It does it by landing on a cell, creating hundreds of copies of itself, which then go out and land on other cells. So that's the way I think a realistic visitation would take place. Maybe they're already here. Maybe they're already on our moon. I don't know.
100% sure of extraterrestrial life?
I would say near 100%, because if you calculate how many planets are habitable, well, we have 100 billion stars within our own galaxy. Half of the stars probably have planets, a half. Maybe 10% of them have Earth-like planets. Maybe 10% of them, in turn, have liquid oceans on them. Maybe 10% of them, in turn, have microbial life. And you just do the math, and you come up with a few thousand. A few thousand planets just within our galaxy should have intelligent life. So how come they don't visit us? Well, maybe they made the transition from type 0 to type 1, from being a primitive civilization like ours to becoming a planetary civilization, but they never made it because of global warming, nuclear warfare, biotechnology, to becoming that could in fact explore the galaxy.
Kaku is the website, mkaku.org, if you'd like to get in touch with Dr. Kaku. Bo, Washington. Go ahead, Robert.
Dr. Kaku, my pleasure. Just a couple of short questions. Why does the Earth spin on its axis? Is the tilt approximately 23 degrees, is that an accident? And lastly, why do other celestial bodies not spin? Okay, I'm finished.
Okay, well, first of all, we think that the Earth was hit by an asteroid perhaps 3.5 to 4.5 billion years ago. And other planets also were hit by an asteroid. In fact, if you take a look at Venus, Venus spins backwards. All the planets go in the same ecliptic plane because we came out of the sun. Venus, however, in its own axis spins the wrong way, spins backwards, because we think it was hit by an asteroid during the age of meteors, the chaotic period during the formation of our solar system. Mars also tilts at 23 degrees, but Uranus tilts 90 degrees off the ecliptic. Think of a rolling barrel. A rolling barrel is very much like Uranus as it spins around the sun. So we think that the first billion years of the creation of our solar system was quite chaotic. We see evidence of this on the moon. Every time the moon comes out, it's pockmarked, and those meteorite craters date back to the age of meteors during the first billion years of our formation of the solar system. So it turns out that all these are artifacts. The fact that planets spin, the fact that they spin on their axis in a certain angle, all of that is due to the chaos of the first billion years of the formation of our solar system.
Next call for Dr. Kaku comes from Tampa. Hi, Tampa. Philip.
Hello, Dr. Kaku. How are you doing? It's a pleasure, and I want you to know that I'm a fan.
Thank you.
And the question I have is two questions. One, how difficult is it for a theoretical physicist such as yourself or a scientist to believe in possibly creation? And what's your take on always the struggle between creationists and evolutionists? The next part of the question is it wishful thinking to think that as old as the Earth is, and as far as we are in evolving, that there's some other planet out there, planet X billion light years away, that's going to be exactly like us? Could it be that we'll never be able to communicate with such a life form?
Well, you asked some very interesting questions. First of all, just last week, astronomers did identify a planet 20 light years from Earth that seems to be almost like a carbon copy of our Earth, capable of having liquid oceans. But as you point out, communicating with an intelligent civilization in outer space is quite difficult. It would take 20 years for a signal from the Earth to go to that planet, another 20 years for a return message. So a conversation would be impossible. It would take 40 years just for a round trip to this nearby planet. So the only way we can make a dialogue with extraterrestrials is if they come visit us. If they land on the White House lawn, then of course we can have an intimate conversation with them. But a conversation with a distant civilization would be impossible simply because of the time it takes to go back and forth. And also, by the way, I think that some people think that we should try to communicate with these extraterrestrial civilizations. I don't think so. I think we should find out what their intentions are first. Look what happened to the Aztec Empire of Mexico when they encountered Cortez. Montezuma made the biggest mistake in history when he thought that Cortez was a god, when in fact he was a plunderer, a bloodthirsty plunderer that destroyed the entire Aztec civilization. So I think we should wait. There's no rush. Once we do find messages, eavesdrop on messages from alien civilizations, we should just take it easy. Wait to decipher their language, find out the level of their mathematics, and then make contact with them once we realize that they are in fact friendly and have no hostile intentions toward us.
Please clarify the shape of a black hole for the many of us who are still confused. This is an email. Does it appear as a water drain that all things fall into? If so, what would the side view or the bottom view look like?
The typical view of a black hole is incorrect. However, it is difficult to explain how black holes look because, of course, they bend in the fourth dimension. First of all, everybody knows the funnel idea. You have like a whirlpool with water falling in this way. But you see, black holes are basically spherical. They're spherical. They're like a ball. So what is this funnel? that funnel is only a representation, a three-dimensional representation of a four-dimensional object. You cannot draw four-dimensional objects on a TV screen. That's why we have this fiction of having this whirlpool. However, there is a black hole you can see tonight. Just go outside, look in the direction of Sagittarius, and there is a raging black hole in the direction of Sagittarius. It's at the center of the Milky Way galaxy. When the Earth goes around the Sun, some people say, well, what does the Sun go around? Everything goes around something. The Moon goes around the Earth goes around the Sun goes around a blank. Well, the Sun goes around a black hole in the direction of Sagittarius. We can't see it yet. Our telescopes are not powerful enough to peer into dust clouds to actually see this object, but we think it's going to be spherical. It'll be spinning, but it's going to be spherical. It'll be basically a black sphere. That's more correct. However, if you fall through the event horizon, most books say that at the very center of a black hole there is a dot. And as you go hit the dot, you die. That's the old picture. We don't believe that anymore. All black holes that we see in outer space are spinning. They're spinning rapidly. The equations say that a black hole should collapse into a ring rotating very rapidly. And if you fall through the ring, you don't necessarily die. You can fall right through the ring into a parallel universe. So a black hole might possibly be a gateway to a parallel universe. We'll never know because, of course, it takes thousands of years to reach one. And if you send an object through the ring, it's very difficult for the object to come back out and tell you what's on the other side of a black hole. But the mathematics seems to indicate that there's a looking glass at the center of a black hole, that this ring is the frame of Alice's looking glass. And if you put your hand through the ring, your hand does not destroy itself. It actually winds up in a parallel universe.
Michio Kaku is our guest on Book TV's In Depth this month. We have about a little less than an hour left. Woodside, California. Rich, hi.
Hi, Dr. Kaku. My question is one of the Dirac experiments, one of the thought experiments. You spoke earlier of Einstein's thought experiment with regards to the speed of light. I'm wondering, have physicists ever, because we know that energy and mass are quantized, have scientists ever done a thought experiment on what it would mean if space and time, which are thought to be continuous, are in fact quantized?
We scientists, Rich, have thought about the possibility that maybe there is a shortest distance, a shortest amount of time. We can divide time into smaller and smaller slices. And so the question is, when you move, are you actually going through many time slices? Or distance, how finely can you slice a distance before you hit the ultimate distance? At the present time, we see no such lattice structure, as we call it, no discrete structure. We have the Large Hadron Collider, which allows us to calculate trillionths of a second, which allows us to measure distances and times that are just astronomically small, unbelievably small, and we see no gradation, we see no choppiness in the structure of space and time. However, once you go to string theory, then there is a possibility that there is the shortest distance. If you take a look at string theory, there is something called the Planck length and the Planck energy. The Planck length is the size of the string itself. It is the smallest object you can create in string theory. So in some sense, maybe there is such a thing as the smallest distance, which is the size of the string itself. The Planck length has also associated with the Planck energy. The Planck energy is the energy of the string itself. If you could somehow access this fabulous energy, which is 10 to the 19 billion electron volts, that's a quadrillion times more powerful than the Large Hadron Collider. At the Planck energy, space and time become unstable. Now this is amazing. You know that when you heat water, eventually it boils. But what happens if you heat space, empty space? According to the theory, if you heat empty space up to the Planck energy, then space and time become unstable. They begin to form bubbles. They begin to form perhaps wormholes, gateways to other universes. Of course, we can't do this with our accelerators, but maybe in the future, an intelligent civilization will be able to harness this fantastic energy and literally become a god. literally create bubbles. These bubbles expand rapidly, and they are the Big Bang itself. So in some sense, you become a midwife to the creation of a new universe. So if it is possible to have the shortest distance, it's also possible to access what is called the Planck energy. And at the Planck energy, these tiny bubbles form, and these bubbles represent gateways to other universes.
Mary in Denver sends a long email, but she says, thank you for your book, Physics of the Impossible. Read it many different times, given a copy to everyone that she knows. Loves your program on the Science Channel. She has several questions, but I just want to pick out this one. Do physicists always need to get PhDs, and where are physicists most needed in your view?
Physicists, I think, are most needed creating the inventions that will generate prosperity and wealth. Think of the 20th century. The 20th century was a century of physics. What did physicists invent? The answer is everything. Who invented the MRI machine? Who invented the PET scan that we use in hospitals? Who invented radio, television, microwaves? Who unleashed the force of antimatter? What about the laser? What about all the fantastic technologies we see in the 20th century? All of them were either invented by or were midwife by a physicist. So where are physicists most necessary? To create the technologies of the 21st century. That's why we have to make an investment in hard science. However, I don't see it happening. Congress is beginning to get stingier and stingier with money. Our educational system is not producing large numbers of physicists. The Chinese, of course, clearly understand the importance of physics. That's why they send their students to Europe and the United States, and now they want them back in order to energize the Chinese economy. So the danger here is that we may have lost the edge. We had the edge during the time of Edison, during the time of Ford, making automobiles and making light bulbs and exploring new frontiers of technology. Have we lost that edge? Maybe. And I think that's a very dangerous situation to be, especially with hungry countries like India and China coming up the ranks. They know the importance of hard science. They send their kids to America and Europe to learn all the hard science, and now they're beginning to woo them back. And so that could deplete our ranks if we cannot attract the finest students, if we cannot generate our own homegrown scientists here in the United States.
But Dr. Kaku, throughout your books, you give examples from universities all across the country, Duke and MIT, and in Europe, Vienna, etc. It sounds like we're still doing a pretty good job.
We're still doing a pretty good job. However, it's not stable. It's not stable into the future because of the fact that other countries are rising. They know very well the importance of hard science for their country. They take the finest minds and send them overseas. China, for example, has what is called the Cuspy exam. They take 1 billion people. Take the university kids, give them an exam. Take the brightest of the crop. These are called Cuspia students, and they send them to Europe and the United States where I meet them. Okay? So I understand that these are some of the brightest minds that were culled out of a population of over 1 billion people. And a lot of them stay in America. They energize Silicon Valley, but now they're being moved back to China, and it makes news in the New York Times when that happens. So it's something that we have to be careful of. We don't want to rest on our laurels. That's what I'm saying.
Rhonda in the Florida Keys, please go ahead with your question for Dr. Kaku.
Hi, Dr. Kaku. What a pleasure to finally say hello.
How do you do?
My husband and I have always practiced the art of manifestation, and that's the power of positive thinking. Actually, I have a small theory of reality equals intention over energy, and I followed your shows for many years instead of going on dates. I have to say that I don't understand if we know that in experiments, the observing affects the outcome. How come the rest of the world doesn't understand our message to you is how come they cannot make change happen? How come we have terrorism and negative thoughts? What can we do to affect change that we need if we are indeed co-creators with God or the energy?
All right, we got the idea, Rhonda. Well, Dr. Kaku.
Well, you ask a lot of very interesting questions. First of all, you're right about positive thinking. As former President Eisenhower once said, a pessimist never won a war. A pessimist never won a battle. Pessimists do not make history. History is made by the optimists who dare to challenge, to be able to unveil the secrets of Mother Nature. So first, we have to have the will, we have to have the curiosity, we have to have the preparation. And you mentioned intention and energy. Yes, you have to have the energy. You have to make the investment in order to make these things possible. And you have to have the intention. But so many times we have people who don't like that. People who feel comfortable being 500 years into the past. People who like theology. People who believe that the word of nature comes not from nature, the word of nature comes from a book. And I'd like to tell this story that I mentioned in my next book, Physics of the Future, coming out in March. If you were an alien coming to the Earth in the year 1500, the year is now 1500, and you're an alien from Mars landing on the Earth, what civilization do you think would eventually dominate the Earth? The Europeans, the Muslims, or the Chinese? Who do you think would dominate? Well, the answer would be obvious. Anyone but the Europeans. The Europeans were mired in the Inquisition. They were torturing their finest scientists, burning their heretics. They were mired in the past. And then you had the great Chinese Empire, discoverers of gunpowder, the compass. You had the huge armies of the Muslim Empire. They were the ones who created algebra. Al, it's the word the in Arabic. The stars were named Algol, Altair by the Arabs. They had optics. They had algebra. They had mathematics. So why did the Europeans eventually prosper? And the answer is very simple. The Chinese turned inward. They created one of the biggest fleets known to humanity in the 1400s and then burned the boats. They turned inward. Same thing with the Muslim Empire. They began to look for words of wisdom, not from nature, but from the book, the Koran. They turned inward. While Europe realized the power of science, technology, steam engines, the Industrial Revolution, electricity, and now we see the differences in the fortunes. So why am I speaking English today? Why am I not speaking Chinese? It's because of science. And we have to understand the power of science, that Europe was the backwash of civilization in 1500. It was a net importer of technology, not exporter. Europe was a net importer of technology, mired in the Inquisition, but it was the beginning of the Renaissance, and that's why I'm speaking English to you today.
Rather curious email here. I don't know if you can help us. What is being built at Michigan State University for the new physics?
That I'm not sure. However, at the great universities, Michigan University, Michigan State, we have vibrant physics departments, vibrant departments in electrical engineering, computer science, but specifically, I'm not sure what that refers to.
Do you know what the Pegasus Project Pegasus is? David from New Jersey.
No, I'm not aware of that.
He says that the U.S. government achieved quantum access 40 years ago. Quantum access means the ability to teleport and time travel.
Well, you probably mean the Philadelphia experiment, right? First of all, there is a Hollywood movie called the Philadelphia experiment where people are able to teleport a battleship, and the military apparently had a secret project in the 1940s. If you go back to the actual history of where that movie got its origin from, you realize that it came from an article where somebody said, well, maybe there was a secret project. In this rumor, it was the military trying to teleport objects. But you realize that we physicists have looked into teleportation. We actually teleport atoms. We've looked into wormholes and stuff like that. These technologies are centuries into the future, and there's no way that the military of the 1940s could have performed what is called the Philadelphia experiment, which is a Hollywood movie.
Martin Jacobson, PhD from West Texas A&M University. Dr. Kaku, in your popular work, you are often drawn into areas outside your training and background. How much time do you spend studying these secondary areas, and what is the most interesting thing you gain from doing so?
Well, if you know physics, then you know the foundational frame by which you can begin to go into other areas like artificial intelligence, like biotechnology. First of all, who created biotechnology? Back in the 1950s, biology was a rather slow-moving science where biologists were giving names of different creatures. That's called taxonomy. But physicists at that time dared to say that there was a molecule a molecule that coded the secret of life. That physicist was Erwin Schrödinger. He was not only the founder of quantum mechanics, but he wrote a book called What is Life? And he said that life itself is nothing but physics. It's nothing but a molecule. Encoded on that molecule is a code of life. Francis Crick read that book. James Watson read that book. And they said, aha, they know what that molecule is. It's called DNA. So it's no accident that it was physicists and biologists that broke open the whole field of molecular biology, which created a whole new era in medicine. So again, if you know physics, you are a giant step ahead in terms of understanding other areas of science.
Glenn, thanks for holding. Freeland, Michigan, you're on with Dr. Kaku. Please go ahead.
Yes, sir. Thank you, gentlemen. You just mentioned Watson and Crick. I wanted to ask, I heard James Watson and a lot of other people say that Darwin is the greatest scientist of all time, and evolution is the best idea anyone's ever came up with. I was wondering if your guest agreed with that, and does he believe that human evolution is finished? And also I'd like to ask him about, he was talking before about the idea that your dead relatives could be in the living room with you in another dimension or whatever. That sounded kind of like ghosts to me. I was wondering if he put any stock in the idea of any of this paranormal kind of stuff a lot.
All right, got it.
Okay, first, evolution. I think if you were to ask Darwin himself how to rank his role in the scheme of things, I think Darwin probably would have said that Newton is perhaps one of the greatest scientists of all time, because he set into motion not just the equations of his mechanics, but a way of thinking that the universe is governed by material forces, not spirits and demons and ghosts, as you mentioned. And that's the Newtonian revolution. However, I would say that if I were to rank the top three scientists who have ever lived, who changed everything around us, I would say Newton, Einstein, and Darwin. They, I think, changed not only everything around us in terms of technology, medicine, bombs, the internet, laser beams, but also our way of thinking about the universe itself. Now, when you talk about quantum mechanics, it does sound kind of spooky. In fact, Einstein himself said this is spooky action at a distance coming into physics via quantum mechanics. But quantum mechanics does not have ghosts, so you don't have to think that mysticism is coming back into science via quantum mechanics. However, quantum mechanics does have this bizarre property that electrons can dance in different kinds of modes, be two places at the same time, exist in parallel states, multiple states simultaneously, and hey, get used to it. That's just the way the world is constructed. We don't see it because we are large objects. We're large objects, these effects largely average out. But that doesn't mean that even though these effects average out, they're not there. As I said before, in your living room, there is the wave function of dinosaurs, because maybe that comet or meteor missed the Earth 65 million years ago because of a quantum event, a solar storm that pushed that comet away, for example. In which case, there'd be dinosaurs in your living room right now, and the wave function of dinosaurs would be right there, including the wave functions of your loved one. So we're not talking about ghosts. We're talking about measurable, quantifiable effects. And quantum mechanics has been shown to be correct to 1 part in 10 billion, making it the most accurate physical theory ever proposed in the history of the human race.
Next call, Dodge City. Hi.
Hi. This is Heather. Am I on?
Yep, we're listening, Heather.
Okay, great. I'm holding a magazine, Life magazine. It is from, admittedly, 1997 still. It reads, the cover reads, Why So Many of Us Now Believe the Stars Reflect the Soul, and in big words, astrology rising. And basically, when you read the article, it says that 48% probably or definitely believe, of those polled, believe that astrology is valid. And I would just like to know kind of, your take on that. And I guess the other thing is just in a more recent, I guess, interview or whatever, watching Criminal Minds, saw Joe Mantegna, the actor, playing David Rossi, and just saying, okay, your daughter was a Leo. She's headstrong. She's this, she's that. So, I mean, it just seems to permeate the...
All right, Heather, we got the point. Astrology.
Okay, let me try to get that one. First of all, I think that our brains are programmed, genetically programmed, to be receptive to these ideas. I think our brains are naturally attuned to look for supernatural, mystical explanations for simple objects because our ancestors that could do that thinking survived. 99% of the time, this mystical thinking failed and it was totally useless, but 1% of the time, perhaps it did give sense and an order to things and allowed our ancestors to survive. I think there could even be a God gene. There we probably are programmed to be receptive to supernatural kinds of effects, and you can actually induce these using physical apparatuses. It turns out that by shooting electromagnetic radiation to a certain part of the brain, you can actually elicit the God effect. You actually feel you're in the presence of a supernatural being, and this could actually be induced. Also, epileptic lesions of the brain have been known to change the way you think. People who have epileptic lesions believe that anything that happens for a reason. Spirits, demons, ghosts. If you fall on the floor today, it's because it was meant to be that way. It's a punishment because of a spirit up there. Some people even think that epileptic lesions may have been responsible for the creation of religions. Joan of Arc, for example, some people speculated that maybe she was just mentally ill. But when you look at the transcripts of her inquisition by the British, you realize that her mind was razor sharp, battling theological questions back and forth. So some historians have said that maybe Joan of Arc suffered from epileptic lesions. So we will have this 1,000 years from now. 1,000 years from now, we'll still be debating ghosts and supernatural effects, because personally, I think that it's programmed into our being, and there's no science gene. Where is the science gene? Where is a gene that says you have to have a scientific method? You have to use mathematics. You have to propose hypotheses and go back into the laboratory. There is no such gene. It has to be learned the hard way. So I think 1,000 years from now, we'll be having questions just like that. So personally, I don't believe in astrology, because after all, these stars are huge. Some of them are much bigger than the sun. Some of them are gigantic star systems. And why should these star systems align themselves exactly so that you'll meet a handsome stranger tomorrow? But I think 1,000 years from now, there'll be conversations just like this.
Dr. Kaku, several emails asking you, what is consciousness?
We don't know what consciousness is. However, I can take a guess. In my book, Physics of the Future, I have to talk about artificial intelligence. At what point will machines become as smart as us? I would rank consciousness on a scale. I don't think there's such a thing as unconscious and conscious. I think that maybe even a thermostat is conscious to a degree. It's aware of its surrounding. So the first ingredient of consciousness is awareness of your surroundings by feedback mechanisms. I would say that even a bug is conscious. It probes its surroundings, looks for mates, looks for food. A thermostat measures its surrounding. I would say that's the first form of consciousness that even machines have. The second form of consciousness, I would say, is self-awareness. If you put most animals in front of a mirror, they attack the mirror. Okay? However, certain primates will not do that. Certain birds will not do that. But many animals will attack the image they see in the mirror. So a sense of self-awareness. And third, the highest form of consciousness is simulating the future. That is, running projections of the future. To the best of our knowledge, animals do not have the concept of tomorrow. For the best of our knowledge, no animal has ever been able to demonstrate a sense of really understanding future projections. Now, apes, for example, will plot to a degree. They'll think about how best to get that banana. But to the best of our knowledge, we don't think animals have the ability to project into the future. While our consciousness, if you think about it, We constantly do that. We say, what will happen if I rob a bank? What happens if I study? What happens if I do this? We constantly run simulations of the future in our mind. And I think that's one of the highest forms of consciousness, being able to run the videotape, create a videotape, run it forward in many different directions to project the future. This is something that we have that animals, to the best of our knowledge, do not have.
Are you currently teaching a class at City College?
Yes, I'm teaching an astronomy course. Astronomy used to be astronomical trivia. Memorize the moons of Jupiter, memorize the moons of Saturn. I mean, who cares? So I inherited that course. It was a very small course, 50 kids. I threw out the book. I imported all the NASA videotapes of going to Mars and flying past Jupiter and the rings of Saturn, brought in videotapes, brought in guest lecturers. Now we're up to 600 kids. Because people want to know, right? For example, sometimes people ask the question, why are people fascinated by Einstein? I would say it's because he was the first messenger from the stars. He was the one who dared to say he can explain what's happening in the heart of stars via E=mc². And the stars are in our dreams. We dream about stars. We're fascinated by the night sky. And here was this man, Einstein, who said, I know. I can give you a message from the universe itself. So I think that was one of the fascinations that people have with astronomy and with somebody like Einstein who could help to interpret the mysteries of the universe.
Michio Kaku is our guest on Book TV's In Depth. About 30 minutes left in our program. Bertha in Riverside, California. Please go ahead with your question.
Oh, thank you. Okay, I have just a couple of question comments. What is your take, sir, on the scientists who have put information about our solar system and about us into a computer and asked it, considering all these things, could this existence have come from some non-intelligent, or just from nothing? And it was every time it comes up, no, impossible because of our integrated complexity involved. And
Bertha, very quickly, you got to turn down that volume on your TV, but go ahead with your second question.
I'm sorry, I didn't realize I was close.
Yep.
I just wanted to ask him about 2012. I saw him on a show recently, and he didn't seem to think there was anything to the 2012 prophecies.
All right, thank you, Bertha.
Okay, first of all, I have a radio program that airs in 130 radio stations. I had the producer, the executive producer of 2012 on my radio show, and I asked him, are you going to be around in 2013? And his answer was, and I quote, it's just a movie. It's just a movie. And let's now take it apart really quick. First of all, the Mayan calendar is cyclical. One cycle ends, another cycle begins. Yes, one cycle ends in 2012 and another cycle begins. But I think some crafty Westerners who have a tradition of apocalypse rather than cyclical universes said, hey, maybe I can write a book, maybe I can get on TV, maybe I can make a lot of money by simply deleting the fact that a new cycle begins. And if you watch the movie, you realize that the planets all align. It's called the Jupiter effect, and they start to rip the Earth apart, the poles shift. Well, the so-called Jupiter effect does happen every few hundred years. The planets do align, and even if they do align, nothing happens because the sun, for example, has a gravitational field much larger than all the planets put together, and we're still here. And that happens pretty regularly. And then in December of 2012, the Earth's axis points toward the center of the galaxy. And that's when the day when everything happens. Well, it turns out that yes, the axis of the Earth does align, but it aligns toward the center of the galaxy once a year. Every year, every December, there is this alignment, and we're still here. And then, not in the movie, but some people say there's a planet X, a 10th planet out there, which is going to rip all the other planets apart. Well, we've looked. We really have looked. At Caltech, they catalog all the comets out there. We do see objects perhaps bigger than Pluto, but Pluto itself is rather small. So we see debris, we see comets, gigantic pieces of rock, maybe a few hundred miles across, but not much else. We don't see planet X out there that's going to come barreling through our solar system, ripping up the world. So I think there is a tradition of apocalypse. Throughout history, people have believed in visions like this, and they've affected American history, in fact, in the 1800s, around 1830-something, where this huge meteor storm that occurred over America terrified Midwesterners. And the Millerite movement started, as a consequence, believing in the apocalypse. They even had a date for the apocalypse. When the apocalypse came and went, nothing happened. The Millerite movement broke into many pieces. One piece became the Jehovah's Witnesses. Another piece became the Seventh-day Adventists. And a small branch of the Millerite movement eventually became the Branch Davidians, who committed mass suicide in Waco, Texas. So these religious movements have a definite link with these prophecies. And the great prophecy of the Millerite movement was a meteor shower that took place.
Michio Kaku is our guest here. His books, Beyond Einstein was his first in 1995. Hyperspace also came out that year. Visions 4 years later in 1999. And then in 2005, Einstein's Cosmos. Parallel Worlds, 2006, and Physics of the Impossible, his most recent in 2008. And coming in March 2011 is
Physics of the Future, where I talk about the next 100 years in computers, medicine, artificial intelligence, nanotechnology.
Arizona. Victor, you are on with Dr. Kaku. Please go ahead.
Yes, sir. It's an honor to talk to you. My quick question was, what's your theory on dreams, the scientific connection between dreams and theory? Reason being, the mineral charts, I forget what it's called, but I know that the guy that actually created that had dreamt that up. The other thing is, I will make this really quick about the alien connection. Me, my sister, and my mother all had the same dream without realizing it until a year later. It was kind of shocking and shocked the senses. I don't know what to think of that. I just don't know.
All right. Thanks, Victor.
Okay, dreams are something that is not well understood by scientists. When people who work in robotic theory start to build neural networks, they seem to have a dream state where they start to reorganize the things that they've learned. So when you build learning machines in the laboratory, they do seem to enter a dream state where they have to sort through all the things that they learn. So perhaps learning and dreaming are essential. That dreaming is nothing but having to reformulate and digest all the information that was learned that particular day. Now, dreaming, of course, has a lot to do with science. The benzene ring, for example. The person who created the pattern for the benzene ring had a dream one day where he dreamt that a snake bit its tail. And then he realized, bingo, that's the structure of the benzene molecule. So here a dream had a direct impact on chemistry. I should also point out that there is a connection between dreams and even aliens. It turns out that when you dream, you are paralyzed. You cannot move when you dream, and that's good. Because if you could act out your dreams without paralysis, you dream walk. In fact, that's what sleepwalking is. Sleepwalking is basically carrying out a dream when you are not paralyzed. Now, when you wake up in the morning, you wake up and you are refreshed and you forget about everything. However, about 5% of most people suffer from what is called sleep paralysis. And that is they are paralyzed when they wake up in the morning. They're in that dream state, they're still dreaming, they are paralyzed, but they are now awake. And they are terrified. They have this image of somebody on their chest bearing down on them as if they are paralyzed and they're helpless. And then they wake up and they forget about it and go about their chores. During the Victorian era, there are paintings of women asleep with a gremlin on their chest, staring down on them. It's even a type of painting that has these gremlins on women's chest. Now, some people today say that, well, we don't believe in gremlins anymore, but some people do believe in aliens. And perhaps, just perhaps, there's a link between people who think they've been abducted and people who wake up in the morning feeling paralyzed. Well, I don't know. It's just a theory that's been proposed out there that perhaps sleep paralysis can explain all sorts of dreamlike states that people have, a feeling of fear, a feeling of somebody bearing down on them, a feeling of somebody doing experiments on their body. Who knows for sure? But there seems to be a link between dreams and aliens.
Alan Weisbecker, Montauk, New York, your description of dark matter sounds a bit like the old theory of the ether, which was found not to exist. Why are you so sure that dark matter exists?
Dark matter, which is invisible matter, makes up 23% of the known universe. In fact, our galaxy would fly apart without dark matter. If you take a look at the Milky Way galaxy, it spins too fast. According to Newton, it should fly apart. It spins 10 times too fast. So what holds the galaxy together? How come the Earth is not being flung into outer space? How come we're still in the galaxy? It's because we're surrounded by a halo of dark matter. Now we have maps of dark matter. The Hubble Space Telescope and other telescopes can look at light that bends as it goes through this invisible matter, like light going through glass. Glass will also bend light, and we now have maps of dark matter. So dark matter started off as being science fiction, almost ghost-like, but now it's firmly in the very heart of science itself. The only thing we don't know about dark matter is, what is it? We don't know what dark matter is. You would win a Nobel Prize if you could figure out what dark matter is. It's just this totally unknown quantity.
Greg in Louisville, good afternoon to you.
Hello, Dr. Kaku. I enjoy your work on the Science Channel and other places. Two quick questions. One, what do you think of the concept of the singularity as advanced by Ray Kurzweil, Singularity University, the genetics, nanotechnology, and robotics advances that they're anticipating? And also, how can I find out more about your radio show? I don't know if we get it here.
Well, first go to my website, mkaku.org, mkaku.org. I'm in 130 cities around the country. It's a weekly science show. I interview 2 top scientists a week.
Can you listen online?
Yeah, you can even listen online. That's right. And
Okay.
it's a talk show. You can even call in. If you have questions, you can call into the show. We have a hotline number and record the question, and I'll try to answer it. Now, about the singularity. Because machines are getting smarter and smarter, then the question is, what happens if they exceed us in intelligence? And what happens if they have children? And the children of these machines are even smarter than their parents, and they have kids. And all of a sudden, you have this explosion of intelligent machines, and we, humans, are left in the dust. Well, first of all, you have to realize where we are today. Our most intelligent robots have the intelligence of a cockroach, a mentally challenged cockroach, a lobotomized, slow-learning, mentally challenged cockroach. That's how smart our machines are today. They take about 5 or 6 hours to simply walk across the room by recognizing objects around them. Very slow. However, we can project that one day they'll be as smart as mice. They'll be able to scurry around, hide, look for food. Then maybe as smart as a dog or a cat. Then maybe as smart as a monkey. At that point, they could become dangerous. I suspect that at that point, we will put a chip in their brain to shut them off if they get that smart. So as we approach the time, when machines become very smart, I think we should take an extra bit of effort to put a chip in their brain to shut them off.
And we'll get Dr. Kaku a sip of water. Bend, Oregon. Kay, hi.
Hi there. What a privilege to get to ask you a question. I have 2 questions, actually. The first one is inspired by quantum healing by Dr. Deepak Chopra. He explained that electrons have an orbit, and that the orbit, it changes when healing happens, and that the leap that happens between one orbit and the other orbit is the definition of a quantum leap, and that in the human body, when a cell replicates itself, it can choose to either replicate itself as it finds itself, damaged or sick or whatever state it's in, or it can go back to the original blueprint in its DNA.
So, Kay, what's your question?
The question is that as they were looking at so-called medical miracles and unexplained healing, they could see that had happened, that the orbit of the electrons had changed. If you were going to apply something into a human being to inspire that quantum leap that happens in healing, to inspire the cells to go back to the original blueprint of the DNA and replicate themselves as a healthy cell, what would be your top best guesses of what to apply to the human body?
Thank you, Kay.
Okay, well, first of all, the electrons do go in shells around the nucleus, and they do jump. These are called quantum leaps, and when they jump, they emit light. So some of the light in this room, the light that floods our world, is due to jumps inside these orbits. And when these atoms bump into other atoms and form DNA, they share the electron. That's what holds DNA together. Why do DNA molecules hold together to give us chromosomes and cells? It's because electrons do share each other as they leap around different atoms. It creates almost a dance, and that's what holds the molecules together. Now, healing, on the other hand, is much more complicated. And however, it's possible that mental states can affect healing because mental states affect the immune system. The immune system, in turn, is our first line of defense when it comes to disease. And so that is very definitely influenced by thinking, because thinking affects our immune system. Our thinking affects the stress hormones that circulate in our body. But, well, I'm not a doctor. I'm not an authority on quantum healing. But it turns out that electrons, as they jump in their orbits around atoms, as they share each other, as they go around the DNA molecule, is the basis for life itself.
Our guest, if you would like to reach him, as he mentioned, you can find it at mkaku.org. That's his website. You can listen to his radio program online at that site. You can contact him. You can buy his books at that site. You can follow him on Twitter or Facebook as well. We have just about 10 minutes left with our guest on In Depth this month, Austin, Texas. Robin, hi.
Hi. Yes, you've jumped around this subject all morning and or afternoon. I was wondering what you thought about if people have created their own aliens with stealth stalking machines, which have landed on all government and institutional lawns, whose competitive jealousy and greed finds enemies of self-ambition, passion, and love to be regulated in.
Hey, Robin, where's all this coming from?
Preference of aligning the stars in their favor of the middleman profit and government control of one's own existence. Do you think that that's gotten ahead, like technology has gotten ahead of people's rights?
Anything you want to respond to?
I don't quite know what the question is, but let me try to just say a few comments. It is true that technology races so fast that morality, politics, democracy has to catch up, in the sense that our brains have not really changed much in 100,000 years. We still have the caveman impulses, the personality of cavemen and women 100,000 years ago, except we have nuclear weapons. We do have biotechnology and chemical warfare technology. So we have to be able to restrain some of our primitive impulses, and I think the way to do this is democracy. Democracy means educating people, informing people about things. And I think that with education, democracy is enforced so that people can democratically make the decisions to control the fantastic power of science. So science by itself is a sword. There are two sides to science. We hope that the democratic side will exercise informed control over this technology. Now, also you mentioned conspiracies and stuff. Some people think that maybe our technology is so rapidly advancing that it must have come from an alien civilization in outer space. Well, I know this technology. I've been following it year by year. I interview the people who created much of this technology. And they say, no, it wasn't God-given. It wasn't given us to an alien. Every year, somebody had to struggle, painfully struggle to create the first transistors, the first integrated circuits, the first microchips. It didn't all of a sudden fall into our laps because we discovered a flying saucer that gave us all this technology. It was year by year, decade by decade, painfully put together by the scientists and engineers who made it possible. However, these scientists and engineers do not have access to the media. No one interviews them when they make such a discovery. And so when these discoveries hit the marketplace, people are amazed. They say, I didn't know that. How come this could happen so quickly? It didn't happen so quickly, but it seems to appear that way, and that's why some people believe in government conspiracies and maybe that this is alien technology from outer space. I don't think so.
Dr. Kaku, if you were to recommend one book of yours for people to read, which would that be?
Well, two books I think I would recommend. One is Hyperspace, if you're curious about the fundamental structure of nature itself. And then I think Visions, if you're curious about the future, that is computers, medicine, biotechnology, nanotechnology, where the future is carrying us. Because these are the twin passions of my life. On one hand, I want to work on the theories of Einstein, understand the secrets of the universe. But on the other hand, I want to know the future. I want to have a sneak preview by interviewing the finest minds who are building the future in their laboratory.
So Visions and Hyperspace are the two that you'd recommend of all of them. Jim, Pittsburgh, hi.
Hi. Thank you, Dr. Kaku, for the opportunity to address you with this question. Dr. Hugh Ross, an evangelical physicist and astronomer that I've followed over the last few years, believes that our species, Homo sapien, did not evolve from earlier species of bipedal primates, but instead was created by a supreme being or God at a unique point in time when our planet was just right as far as being habitable. In fact, he believes that many, if not all, species of animals were uniquely created by an omnipotent God and not through evolution. In other words, he doesn't believe in evolution per se. Does this viewpoint violate the laws of physics, or can a theory of ongoing creationism coexist with the current laws of physics? And if it cannot, can a theory of ongoing creationism perhaps coexist with a future law of physics to be discovered sometime in the future?
Well, let me say just really quick what physics says about evolution. First of all, physics can date fossils. Physics can tell you how old fossils are by looking at the residual radiation in fossils, and thereby we can construct a tree of how different fossils have changed over time, because we now have a yardstick, a clock, by which we could put them in chronological order. And we do see a pattern. We see tree-like limbs, just like the way Darwin predicted. And another thing that we can do in physics is give you the mechanism that makes this possible, mutations. Darwin could only dream about why one species turned into another. Now at the atomic scale, we can see the effects of cosmic rays. We can see the effects of random mutations of DNA molecules. We can see the effects of chemicals. So we now have a physical basis to why animal species will mutate from one form to the next form to the next form. So these two things, first, being able to date the age of all the life forms on Earth, and second, a mechanism that gives us an explanation of why this takes place, gives us a pretty good theory of evolution.
Dr. Kaku, when a star collapses to form a neutron star, the result is an incredibly dense object with a defined diameter. Does all the matter inside a black hole also have a diameter? I've heard a black hole referred to as a point source, but can't get my head around the idea that all that matter can shrink in an infinitesimal size. Can you help clarify this? Robert in Cape May, New Jersey.
Well, that's the $64,000 question. What happens when a black hole collapses to this dot? First of all, when matter collapses, we have to say what is retarding or resisting that force of collapse. When a star collapses to a neutron star, there's neutron pressure. There is pressure of neutrons pushing against each other, and that's why neutron stars are stable. But if you collapse a neutron star, what's left? What is there left to prevent the star from collapsing to nothing? And the answer is nothing. We have no known force that can withstand gravity on that scale. However, we do think that when a black hole collapses, it doesn't collapse to a dot, it probably collapses to a ring. That's what the math says, because these things are rotating very rapidly. And if you have a vibrating ring, a rotating ring, then at the very center, you're not going to die necessarily by going through. It could be, in some sense, a gateway to a parallel universe. Then if all the matter falls in and comes through the ring, then where does it go? If it comes out the other end, then it looks like a white hole. So there is a theory, not believed by everybody, but there is a theory that says that as everything falls into a black hole, it goes through the ring and is blown out the other end as a white hole. In fact, there's some physicists who believe that that's the Big Bang. Why is it that the Big Bang is spewing material out in all directions? Perhaps we're a white hole, and on the other side of the white hole, there's a black hole.
Chuck, Tampa, please go ahead.
Yeah, hi, Dr. Kaku. I'm a huge fan of sci-fi science, and for the longest time, I've always been fascinated with physics and how the world works. And I was just wondering, well, for a time, I have these ideas and thoughts that I just think of, and, a couple years later, it'll kind of put itself together with the way the physics work. But I was just wondering, how do people like me who, we have a lot of imagination, but we aren't physicists per se, so we can't crunch the numbers on stuff. How do we get our ideas out there? And, maybe one day they would actually sort of, come together.
Hey, Chuck, are you a student?
Yes, I'm a student at FSU.
Oh, okay. And what are you studying?
Right now I study theater.
You're studying theater, but you have physics ideas.
Yeah, I've always been extremely fascinated with physics and with astronomy. I just have a huge curiosity for the way everything works, but I just don't think I'm really smart with the numbers.
All right.
Okay, I get a lot of emails from people saying, I have a theory, or I have an invention. What should I do with this? First of all, if you have an invention, get a patent attorney. Get it patented. If you think it's good enough to survive in the marketplace, hey, maybe you could be the next Edison. Who knows? Get a patent attorney. Start to think about getting a patent. If you have a physical theory, you think you're better than Einstein, or you have a new insight into black holes and exploding stars and things like that, get it published. You can write to the various physics magazines that have referees. The referees will then look at your work and then try to pick it apart or maybe vindicate what you're doing. If, on the other hand, you just have a general idea, an idea without mathematics, so you cannot be submitted to a journal, then, of course, you can publish on the web. Lots of ideas are on the web. It doesn't guarantee that it's going to get a lot of readership, but at least you can get it out on the web. So for people, however, who are serious about this, you do have to, at some point, confront the math. That's what separates the amateurs from the professionals. The professionals can then be very precise, be very exact, make predictions from this idea. But again, if you don't have the math, you can always publish it on the web and then invite people to take it apart or go on blogs. Some scientists, my colleagues, have their own blogs, and you can earn the attention of other scientists and other learned individuals by writing blogs on the website of a scientist.
mkaku.org is Dr. Kaku's website. Do you have any patents?
No, most of what I do is purely theoretical, and we don't have enough energy to create any of the machines that I write about in my books.
All right, Barrington, New Hampshire, almost out of time. Please go ahead.
Dr. Kaku, sir.
Yes.
I have one question. Well, actually, I have about 10 to the 19, but I promise this will be one question, and it concerns gravity. I'm about 58 years old. I'm interested in everything that ends in ology, pretty much. But with gravity as one of the forces of the universe, all my life I have been concerned about or curious about what generates that force. And if I might, I'd just like to add.
You know what? We're out of time. We're going to have to go with just that question. Go ahead.
Okay, well, no one knows what generates gravity. However, we think that if space is like an arena, and we are subjects dancing on this arena of space, the arena itself could be curved. So the curvature of space immediately looks like a force. If you walk on a stage that is warped, it looks like someone's tugging on you. That, Einstein said, is gravity. Gravity is nothing but the curvature of space. The problem is when you quantize it, all hell breaks loose. And that's why we physicists have plenty to do in the coming decades, is to quantize the theory of Einstein.
Michio Kaku has been our guest for the last 3 hours on In Depth, and my head is swimming. Thank you very much for your time and for sharing your knowledge with us. Here again are his books. Beyond Einstein was the first one. Hyperspace, A Scientific Odyssey Through Parallel Universes, one that he recommends if you're only going to choose one or two of his books to read. Visions came out in 1999. That's the other one he recommends, again, if you're only choosing one or two of them. Einstein's Cosmos, How Albert Einstein's Vision Transformed Our Understanding of Space and Time. Parallel Worlds, A Journey Through Creation, Higher Dimensions, and the Future of the Cosmos came out in 2006. And Physics of the Impossible, A Scientific Exploration into the World of Phasers, Force Fields, Teleportation, and Time Travel. His most recent, coming out in March 2011, is
Physics of the Future, about the world of the year 2100.